how would that mount?
There's like those little brackets that get bolted into the compartments. They have a pretty big surface area to epoxy to the tube.
Oh, it's. Yes.
Oh, just because the way it's big. Yeah, I can decide what you. Wait, let the color television.
Why? You can click it with my laptop. Okay, so I'm still wait, if you join on your laptop, you also join here, right? Oh, okay.
It's like
Oh, yeah, wait.
Alright, so this is the bin can, has an interface centering ring, it has that, grab button up there. Going console section, 2-inch cylindrical section and a 12-inch console section. Got the measurement for all the dimensions of it. And then the 3400 motor casing has a like this circle right here, 4 diameters, or 4 inches in diameter. There you go. And so the aft diameter of the boat tails is 3.9 to account for the wall thickness. So there is an overlap there, which is going to allow for the pressure transfer. Yes, not 4 diameters. Okay, so this is a unique requirement. For those of you that don't know, we are now required to do shear modulus determination for our fins. So this is our plan of action for that. So we are going to use the HSM E7078, which is designed to determine shear modulus of both composites. So pretty good for us. This is kind of a rough idea of what it looks like. We are looking to see if anybody on at case will let us use there. That's Rob, you didn't have it. But in the case that we aren't able to get it, we can just machine the jigs that are needed for the test. So that's the plan. We can't find anything in case. And then the 27 kilonewtons approximately is the max force for the Entron machine that I plan on using. But if we get that number, we should be fine. And then here are the required forces. Oh, that's what I just said. Max force load cell, machine from some conditions. Anyway, so for a 0.35 inch thick specimen, rating force 25.2 kilonewtons. And then what we're going to do this with is the fins from last year, like there's leftover carbon fiber plate on or carbon fiber layout on top of the G10 sheet. And how we're going to use that because we would use a similar fin material this year. So we're going to use that, and then we'll do a layup on top of it, like thick slab of carbon fiber, in order to see which one is stronger, and then which one is stronger onto the rocket. So. But as mentioned,
It'll probably go away.
Probably go away. All right. I don't know. I'm good. Yeah. The height that everything's happening now. Here's the recovery scheme. So it's gonna launch. That's what it's gonna look like. All one rocket. Then with the hit apogee, the floating charge is gonna pop open. Shear pins are broken. Nose cone's gonna come off, and then the drogue's gonna deploy, and then gonna descend 1,500 feet. The tendy's gonna, the EMAX and the tendy are gonna pop the ends out, releasing the main parachute. Then it'll have a safe landing. Yeah.
Cool. So yeah, this is just basically the numbers of the flight. We have an apogee of 31,000-ish feet, going Mach 1.69 and 471 feet per second squared. The rest of the numbers you guys can read. I'm not going to read out every number. One thing to note is in the DTEC, they now specify stability based on percent length of your rocket, not body cells. Because I think a lot of us are still like very intuitive to body counts. I did the conversion for you. So we'll go over this in compliance matrix, but the minimum for supersonic flights is 10% and the maximum is 25%. So we are within that. We actually end up having the opposite problem because we did put up, we were overstable and had to come down. But yeah, and then this is also calculated based off RAS arrow. It's calculated based off no wind. So like that's how they said to do it. In the detail how I said. So yeah. This is gonna be a bunch of graphs. So this is all of a rocket flight scheme. This is with wind. Like accumulated Midland with all of the averages of June. This is the flight scheme, altitude, vertical velocity, vertical acceleration. I'll let you look at it for a sec. Then this is RAS arrow, the altitude from RAS arrow, the velocity, and the acceleration. And then this is also the stability based on RAS arrow. Like I said, our minimum is 15 and our max is 24.6%. So in that, but it shows it in columns as 3%. So we did those conversions. But yeah. Fin flow calcs, these are the inputs. The main takeaway is we have a 4.58. These are the inputs. You wanna stare at them for a sec. The semi-span is calculated based off of, like, we say off into like 6 inches, but because the boat tail is slanted, it's like 6 inches plus whatever the slant is gonna be, so we calculate based off of the maximum value that it could be. So it's 6.828. But yeah, these are our inputs. And then
Go back.
anything specific to me go?
The material.
The material,
That's-
the materials is based off of, we have once we have plastic, we can make our custom material, and do it. The material right now, which is, we have a carbon fiber reinforced plastic, it gives us the worst now, but it has like 2 options in Vincent, we just pick whichever one gives us a lower value, and go over that. But yeah, once we have, do testings, we can make like a custom material for those properties. So that'll be cool. Am I good? Speak now. Before I continue, the main takeaway is we have a factor of safety of 1.58, which our minimum required and 1.5, so we're chilling on fin flutter. Cool. Hopefully. No, we're chilling on fin flutter, don't worry about it. We also have more fin analysis. This is CN alpha. So I realized in putting out we didn't explain what CN alpha was like on a full slide. So here's the slide view. It's basically the slope of thought. CN alpha was the angle of attack. It quantifies the magnitude of soaring force the thing gives based off of like how steep your angle of attack is. So like it's slanted, like how the force is pushed back. A larger value is seen out for preferred since we want to be able to push the rocket back up to being straight. And just the general rule of thumb is not fair.
We could.
The general rule of thumb, okay, is vicinity above CN alpha of 10. And the graph is like CN alpha versus Mach number. So we can see the graph CN alpha here, and we are not going above Mach like 2 or anything. So like around halfway here, so we stop, and as you can see for all the Mach numbers we're gonna hit, you're above 10. So we're good. And then here's the dynamic pressure of the rocket. Maximum dynamic pressure, also known as max Q, is 140 kilopascals. This is important to know because why we think, or where we think EOS went wrong last year. But these are just graphs of dynamic pressure over time and dynamic pressure versus altitude. But I also have velocity of which we hit max Q. I'll stay on the site for a second. You guys want to take a look?
They should determine the altitude that that's the thing we're at.
Yes.
8,000, I think has. We're at about 8,000 feet elevation anyway.
Hello.
Alright, so the one tapping is here.
Yeah.
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 Is that you, Karen?
So the Lone Traveler, we're gonna pretty similar design, as last year, it's gonna, we're gonna use the M 1939. So the forward closure of that casing is gonna just thread on that lower bolt, and then that lower bolt obviously connected to the tumbler, which we're planning by the white force, and then that'll connect to the top bulkhead, which will then like thread into the door transfer bulkhead like normal motor does, basically kind of just like extend motor, not actually big. Yeah, and then you're using threaded rod to connect this because epoxy is not much modeling and there's nothing on the exterior, so we're just gonna use threaded rods to slow lines. Oh, and then here's a better picture of it with the Loctite going on there. So red Loctite will be on everything that doesn't have to be removed, so it's gonna be on the door transfer, and then the bulkhead on the bottom, the door transfer coupler, and the blue lock and everything else. The blue lock and everything else. And this is like better picture of how it all connects together. So through the simulation, but for right now, open rocket that we use for test the simulation. This is based on the fully mid. Okay, guys, I just read it online. Okay.
I might have missed it, but do you have the same thing for the lock conditions of the actor lock?
We don't, but that's in Kodiar and we probably should.
Yeah.
Yeah, but they're all, but you already know one of these, not even going past the sound, so I guess the big thing is the app. Big thing is the apogee, I think. What is?
Single coast is 16,500 feet, so yeah.
So we're not pushing it really. Also, and stability changed a little bit, it's a little more stable off the rod, and that's. Breaking up. Oh, and it's up. Also, I don't think we showed a diagram anywhere, but we did add like the on top of stuff, the weight, everything. Alright, so I did invested with. In play team. Let you guys look at it for a couple seconds.
It's a grab.
I'm sorry to
A second, you won't notice something drops.
You guys have slides. You guys can see, and then this is Max Q. This also determined the fin flares, you'll see, because triple has an elevation of around 1,000 and then Max Q is like 2,000 or 3,000. We tested it for, so and this is this.
But we're going in different.
Well, your water was just paying like. But your house is different.
Yeah, or like
It's a little more dense, not by nearly think factors or something.
Well, it's good to do the math, like it's not bad. Keep going.
I also, or I didn't put it on here too, with the fins on, we're not.
Oh, great.
Yeah.
There was.
Did I miss them?
On this one or on the,
Yeah.
I was talking there.
It's
there. It's all there.
Right under.
Alright, that's just one.
I guess the factor of safety isn't calculated, but it's less, so. I know the factor of safety.
You should have two.
But it's always.
But like, if you hit one, you get water, it doesn't matter, so.
Alright. In what compliance matrices, there was some new DTAG. No. There's some new DTAG requirements, because the 2060 came out. So we're gonna look at those now, and also everything else. In terms of general requirements, we have rail buttons. Yeah. We have 2 of them, and they're really cool. We see and then some novels requirements. Electronics requirements, we have this because the camera eBays were a little last minute, so we put those on. They have batteries that are fine. And they're doing requirements, so that's why we got some site. This is just your camera eBay. Hey.
Nicer. But you can't just say,
No, batteries are not what is not allowed. That's it.
So, yeah, we house a lot of components properly, things can't rotate or translate. We're able to house 2 cameras actually. And we have 3 camera holes for those cameras, so, yeah, we have 7.5 inches of clearance for recovery space, which is more than what we need. We are more than 2,000 feet below the Timber Flag River, so we're showing that. We're able to house ballasts with the camera eBay, the lower camera eBay. The motor contrast they rotate. Yeah. Both requirements, apogee is between what we're hoping to be reaching for at this moment. For both like actual launch and for low launch. These are the new DTEC requirements. The static stability margin. The static stability margin does not exceed 18% of the length of the rocket. The minimum is not greater than 25%. Oh, sorry, the maximum is not greater than 25%, and the minimum is not less than 10%. We're within requirements. And then overall aerodynamic requirement, FOS on thin floater is 1.58, which is about 1.5. Especially for the screen. Half extent expand is 1.12 calibers, which is greater than the 0.8 that the DTEC requests. And we have a plan to estimate shear modulus. Recovery, we have a descent rate that is less than our maximum requirement. The descent rate of our drogue is good. All our things are within requirements, and you guys can read. We're all within requirements for recovery, and yes.
So here's the risk matrix. There's a bigger spreadsheet with more stuff and stuff will get added as we start moving into like more specific design constraints. These are some of the ones that we've already thought about. So some of the big ones are like spreader rod and through the nose cone tip. That's all about Loctite. Also this time, comment on the last one, we added the risk priority notification file. So
hover over it, I don't know.
Professional angular motion. Yeah.
Then a bunch of these will have to do with projections, like the nose cone bulkhead, the charge wells failing to ignite, or add ejection, the charge is not causing enough pressure to separate, and or the floating charges burn through the parachutes, that can always solve projection testing. There's some more topics particularly bad, recovery line breaking during main deployment, that was up. So we're gonna do the strength test we were talking about earlier. And then we need to do some analysis. Make sure that we're getting accurate deployment forces for the velocity that rocket will be going on descent. So the recovery line getting tangled, drogue not deploying, and main not deploying will depend on how properly we pack the recovery system. So we should do that good. And then some of these ones, main deployment too late would be bad, not terrible. So that's fault injection testing. Bolt sharing. Pretty likely to happen because the bolts are pretty well known for like the strength of them is pretty well known, but we'll run FBA. So ensure that doesn't happen. Potato, won't that happen? Yeah. And then fin floater and divergence we talked about. Calculating max Q, making sure that we're above 1.5 with factor shape, safety, shear modulus stuff. And then potentially we will do CFD to get that started out. But I think that's it for us.
Payload. So theory of operations for payload, the rocket launches the accelerometers, we can begin recording vibration data. The accelerometer that is outside of the damping polymer pocket will measure vibrations experienced by the payload body during ascent and descent. The accelerometer inside of the damping pocket will also measure these vibrations experienced during ascent and descent. And then this data will be saved to an SD card, and upon recovery, the accelerometer data can be taken and
This is the dampening polymer. It's 2 layers of PPE, that are like interlinked, and then there's a viscous layer of basically plastic that's not linked, that will flow basically, and that's what actually does the dampening. It's like a rubber band, except it doesn't stretch back, so it can absorb like all the ink.
Alright, basic CAD structure, each side of the payload, we have pictures of this on the next coming slides. But each slide was CADed individually, assembled in SolidWorks. It's a puzzle piece model that allows for easier assembly, so the different like pieces of the payload, top, bottom, and the sides are all bolted together. The front and back panels of the payload are different, the side panels are the same, and the top and bottom are different to allow for the payload to be secured to the bulkhead. As we discussed in aerostructure, so there we have the top. We're going. Never mind, for one.
Yeah, it's that's the top one. It'll screw into the top, like Robbie said. I mean that'll be fine. We don't need something. The bottom is just a flat sheet. That's kind of over.
Alright, so we have the front panel. We have a view as if you were looking at the payload from the outside, and then the inside. The same thing for the back panel and then the side panels, which are just the same. They have the front and back panels have like a little like divot cut out. It doesn't go all the way through, but it's just like a dip, and that's like where electronics are going to be secured. We're on that.
Yeah, so we're gonna use 6061 for the frame, and then we use PEG for a lot of the electronic stuff, like the voltage, the battery, accelerometers, and all the
Alright, this is the external view of the payload model. It maintains a 3U CubeSat. Top and bottom dimensions are 3.94 by 3.94 with a 23.8-inch thickness. Side panel dimensions are 3.94 by 11.81 tall and 0.38 inches in thickness again. Once again, connected puzzle piece method. The side top panels fit together like a puzzle with a CubeSat shape. And they're all bolted together. We are still working to decide on the bolts that we're.
So inside, there's a little more explaining later, but it's gonna have the accelerometers in the two accelerometers. One of them's gonna be covered in a polymer, and then the other one's just gonna be the accelerometer, and they're both gonna be in a Pepsi encasement on the bottom. And above it, it's gonna be like a little like ground, a little heat that slides into the tube, that's gonna hold all of the microcontrollers and the breakout boards. And then there's two speakers above that connected to that. So it's a little, you can see it come out, that's the piece that will slide in, that's all the chips that we're getting.
So a little bit on the power draw analysis, the different electronic components, followed by the voltage that they need to run correctly. Their current draw in milliamps, the operation time, the expected operation time in hours, and then the needed battery capacity in milliamp hours for all of these devices.
So these are electronics using an HP32 in measurement seasons to pull the thing on. Plus using a temporary flash, there's a tiny enough code, but it can hold the vibration. There's two accelerometers, there's data, 134, they're like 20 kilohertz, grade. Then we have the bulk converter that has a 3.0, two 650s, then that board will once we recover, we'll be able to place that decode there and collect all the data. So this is the how it's gonna work. The batteries which can switch for bulk converter, then that'll power the microcontrollers, then accelerometers and data, the code, and the battery. So this is a Y diagram. You see everything's SPI, which is what Yeah.
Right, bulkhead connection, payload as pretty much was discussed by air vectors, will only connect to the lower bulkhead head because there's a factory of safety of 30, pretty much 30 on it from last year. And it survived the ballistic impact of last year, so, based on that, we determined that it only needs to be connected in on one bulkhead. It'll be bolted to the lower, bulkhead with ports. Why am I these? Yeah. So. Okay, cool. So seeing here the overall requirements, we're not using any pyrotechnics. It's gonna be labeled, it's not gonna contain any live vertebrate animals. It doesn't contain any lead or other heavy metals, so that exceeds that requirement. It does not contain any radioactive material, so it exceeds that, requirement. It'll not use any prohibited batteries, we're just using pretty standard batteries. Here are our experimental requirements. It conducts a pretty relevant experiment. This experiment is very interesting because it could be used in future space flight for like how things are stored during flight so that they don't experience extreme vibrations. So that's pretty interesting.
Yeah, I mean, it'll be 5.5, 5,000, and it.
The 5.5 pounds is the current weight. This is subject to change during mass. Then recovery requirements. We're not using anything deployable. It's no more than one independent body. And we're not deploying it, so it doesn't really need CO2. All right.
Alright, well, so here's the presentation for the measured subsystem. So first we're going over what our eBay looks like. It's a lot different from how it looked like in Kodiak. But what we're trying to go for now is a fully 3D printed eBay design, probably be the PET-G. And we just keep connecting all of our components onto the surface here. So I was another big difference. So I mentioned Kodiak, we're not using the logic anymore. So we're using Arduino Nano as our main data acquisition device. We'll also be having an ADC, which analog to digital converters to convert the analog data from the strain gauges into a digital signal that will then go into the Arduino. We also have level shifters and a buck converter, which I'll get into and explain our wiring diagram. And of course, we would have our batteries, and we will also be using the AP650 the amount. And also, as I mentioned, we do thread routes for. Okay, so just going our eBay stability calculations. There's some math here, which I pulled most from PC310, but from most important point is the factor of safety here, which I got factor safety of 89. And there's some measurements for dimensions of mass and center of mass, which I pulled from SOG or SOGAR eBay stand, and then also a source for PET-G physical. Yeah. Okay, then this is another something I wanted to show that's not necessarily part of the eBay, but goes where each strain gauge goes. So I've been talking about this component here, it's the strain gauge module that has the strain gauge itself connected to a Wheatstone bridge with op amps on it just to clean up the data. And so the main problem we wanted to solve was how do we actually connect this to the inner lining of the tube. And so we came out with is a holder like this with a surface in the bottom that forms to the tube that we could just epoxy, probably use like Scotch weld to epoxy to the tubes. And then we just then glue the strain gauge holder onto the strain gauge module onto the holder, where and then this holds other stuff we can go in all the locations that we want to put strain gauges. And so about where we want to put strain gauges, I was thinking of adding strain gauges in these 4 locations. like Robbie mentioned, or like President mentioned, in their presentation, we'll be running wires along from our eBay over there to at least to two locations below bodies loop, one that's close to the thrust transfer bulkhead, and then one close to fins. So we'll be having, so these bulkheads in the middle and centering rings will be accounted for wires that will be running through. And then we'll also be having strain gauges near the protection bulkhead, the separation point, and then we'll also be having strain gauges right below the nose cone bulkhead, so we'll have wire crossing the separation point. And so here are my specifications for why we want to put strain gauges in these locations. So nose cone eBay is just to measure the information of the nose cone, is the first part of the object that with that saying. Recovery bulkhead, this is a more special location, since we're not considering the strain gauges on the carbon fiber tubes, but actually on the bulkhead itself. So, and of course, just to measure what how the bulkhead deforms when recovery deploys. Thrust transfer bulkhead, since that is going to be radially bolted, we can strain gauge the carbon fiber surrounding the carbon fiber tubes surrounding those radial bolts to see how the deformation of those thrust transfer bulkheads cause deformation in the carbon fiber tubes. Okay, how the thrust transfer causes deformation in the carbon fiber. And then lastly, we'll put strain gauges close to the fins or in the fin can, sort of an indirect way of measuring the deformation of the fins that have strain gauges with the okay, here are the battery calculations I've done. So most important thing here is we're assuming that we're not using any screw switches, so everything's gonna be powered the moment we connect everything. So that's why I've had operation time as 14 hours for this requirements we set. Some of these current draws we haven't measured. We were able to measure the current draw of the strain gauge modules themselves. And the Arduino Nano, that number came from the current draw used by Halo last year, and they used Arduino Nano, so we used the number for that. For the ADC and the level shifters, I'm gonna be honest, those were like over estimates we had, but after this, since we just got components, we'll be doing tests on what the current draw looks like. And so then from these calculations, we decided we'll be using 4 18650 lithium-ion batteries. And then here is kind of like how exactly we want to use these batteries. So the plan is to use, since we have 4 batteries, we'll have 2 pairs connected in series with each other. So since they're connected in series, each individual battery has 3.7 volts at 3,500 milliamp hours of capacity. When you connect them in series, you get a voltage of double the voltage to 7.2 volts. However, the battery capacity remains the same. So one pair of these in series batteries can connect directly to the Arduino Nano. The Arduino Nano can take in a voltage power input of 7.4 or can take in a voltage of 7.4 volts, and all the batteries and all the components that require a correction. And then the Arduino can then output a 3.3 voltage to all the components that require 3.3 volts to run. And the current draw we estimate the capacity needed to power all the 3.3 volts is 1225 milliamp hours, so way below the 3500. And then for the second pair will be used to power all the 5 volt components. So since the Arduino can't output a 5 volts power output without a bunch of stuff like that, but we decided to use a buck converter. So the buck converter will basically take that 7.4 input voltage, spit out a 5 volt voltage, and in that process, it actually increases the battery capacity. And so here I show the calculation, assuming that it's an 80% efficiency buck converter. And we end up with 44 milliamp hours capacity from that. And all the 5 volts and all the 5 volt components need 45 milliamp hours, so again, they're still above. And then here's the wiring diagram. What's this? Oh, this bottom box here is flat, extra flash of the factors are redundancy, because we want to store on Arduino, but just in case. Have another build for storing it. And then here's our compliance matrices. The most thing is since we've done calculations for battery, we can make that sheet and say we're able to get way above the prior 14 hours. And the other thing we know now, since we know what components we're using, we know we can actually sample the data at a frequency of 30 kilohertz, which is way above the 500 hertz requirement that we set. So that's what's good.
Wake up.
Alright, so, first just want to start off with some general updates from how we enjoy. Perhaps the largely made numbers from my eBay components, as you may have shown, this shown by DCAT and eBay. This is going to be a Siren S103, a featherweight Raven, LGPS, Ellen Beacon, and we have an accommodation for an Easy Mini. We do not intend to use it as a for deploying events, but it is there in the event that things go forward with wrong steering. And all of these can be powered by 18650 lithium ion batteries. The math on that is here. All of these are run at 3.7 volt. Great. Most of the top components have pretty manageable current draws, so we can well extend beyond 24 hours lifetime. I'm going off the 14-hour window from the start of launches to the end of recovery. Perhaps the biggest issue here is with Siren S1R3. Testing on S1R2, we found it draws about 150 milliamp hour or milliamps, which is manageable. We are unable at the moment to figure out the current draw for Siren S1R3. I hypothesize it to be around 200 milliamps. I believe this is reasonable, but if we are going to have to wait until the board is sorted to finalize this. Given this, we are still well within the battery capacity for that, and we have room to upgrade that, so it should go well. And all these capacities are, of course, met by 18650s. Here's the Siren updates. We got the debugger, so we're able to actually write code to Siren out. The GPS reorder was fulfilled just a couple of days ago. So for now,
The date though.
yeah, I guess. So we're now able to order Siren once we get more word on the tariff situations. We're gonna have to pay out 50% IRS for that. But we've got software for the back power and VPS. Almost done. 100% progress. Here's our clients matrices. Oh, dang, okay.
This is your update.
This is update. Yeah, but you can see, I'm gonna go under change from S2, the other things we need to host them, which we're working on now. That's sort of bench this year in radio and that's one of the ideas. Yeah, we still have yet to do testing of signal. Some of that is waiting on S1R3, but most of it can be done before that happens. I'd like to add on that last slide. All of that testing is absolutely essential for SNR3 to be the main flight computer of this rocket. We want to know it works and it won't blow up the rocket. So all that makes sense testing to do that. This is the plan for that testing in the order that we plan to complete it. All of this is contingent on receiving SNR3 very soon. And once we do, we are first going to be testing the code that we know works, IMU barometer, making sure we can actually log data. This is just gonna be like pretty much hooking it up, powering it, running around, recording a quote unquote flight based on that, and checking to make sure all the data lines up. And after that, we want to make sure that it is capable of deployments this time. So this is just going to be using simulated flight data to run a flight, make sure the charges go off on during apogee and at 100 feet. Once we confirm this, we are suited to go on a test flight. This is going to be done by attaching steering to a modified L1 with an L2 motor. This will take us supersonic, making sure we are doing this because we are running out of time. We want to make sure this works. The original plan was to go on a fully functional L2. I believe there are 2 L2s, current 3 maybe. There are many L2s that are designed to work with steering on it, but this is to completely ensure that we do get it tested before we have it ready. The main idea of this is just making sure it can survive the way up. It will fully record all flight data, deploy events, and absolutely will not deploy early. Once this is all completed, we're having a pretty good time now. So we're going to be testing radio and GPS, perhaps some of the least essential things, which is why we're doing them last, because we want to get the out of the way. We're going to be doing this by taking 2 students and having them communicate by sending radio packets with both live telemetry and GPS information. As far as we can get them, just making sure that we still can receive packets, because this was an issue at comp last year where we could get some signal lock with telemetry. We lost it immediately as the rocket went up, and with GPS as well. It was working initially, but one Compton round we were unable to get fixes on satellite, which caused a whole lot of issues.
I wanna add on, so the reason we're also doing a modified L1 is so that the serum explodes. It's not someone L2 that's blowing up, and it's an L1 that, you know, I care about.
Serum not explode.
But like, because then it can go up on an L2 and record data, log data and things like that, we know that it'd be safe to go on someone's L2 instead of someone making an L2 and then blow up his serum malfunction.
That was a great avionics. That's my favorite avionics slide.
Okay, let's take
8 minutes till 7:20.
we're doing good on time. Sorry, we're doing well on time.
Oh, the ground. Holy shit.
And well, question, second run through at 7:20. Prepare your questions. Why can't you? I can hear you.
I was like, I was. Yeah.
I can still talk to him, it just means it's gonna be delayed as fuck.
I see.
For some reason, you.
First of all, so like kind of simple, no, massive entity. Box, so it's.
Well,
Racist.
I said I was in the wiring.
I don't know.
Found out on my. I don't know what they're gonna. Sitting Wang is like, yo, dude, you might find it. Oh, no, you won't find it hard time standing tall. He has access to like.
I haven't gone inside of like.
The only thing it sounds like.
He will, yeah, but it's like. Like, that's something.
Oh, thank you.
Just imagine, small table. It's like 5.
Oh, yeah, I had. I didn't know that, but I totally makes sense. So, there were 13. I have not been paying attention. So sad. So what? So. I was like, you said it was
Last year,
say that. The same. I never expected where. It's so fun.
Oh, I see, I remember last time we had the like handbreakers. Damn, I like a million. But where was
So it's like.
No, what do you mean?
Because I was like,
it's like I want to give the slide.
hello. Saw you right now. Seems so.
Is that, is stuff like actually segmented in this view? Or is the rocket just like?
I think it is generally actually thought in some method.
Okay.
So.
Yeah, in this case.
He just understands stuff.
What happens? Take a picture.
I'm not here with that. Oh, you got
It has to be like anything.
And also one of the bolts not.
Like,
If you have a video,
Yeah, great.
It doesn't inspire joy. That's what. Yeah, you probably.
Yeah, like, yeah.
Kind of know what not anywhere near the people second every time. So put them in the smaller.
I thought. What the fuck? Oh my god. That's because
The Jordan's thing.
Yo.
Oh man.
I had to.
Net zero.
Yeah, I had people in the camera eBay. It was like, oh, I have three, so it's like aligned with
Not
everything
gonna
else.
go.
Yeah. You read at least, I guess.
Also, can we stop using this loaded gun analogy? It really fucking blows.
I mean, that's what it is, kind of. Also, like, I mean, what else would you use?
I don't know, but it's a bad analogy.
Loaded muscle.
Shut up.
See, but no, because it's neither of those, because it's not shooting anything. It's just a tube with a giant explosive.
Well, it would shoot parachutes at you, but that's also not the concern.
Yeah.
Yeah.
It's just contained versus not contained.
Yeah, it's not a good description. It doesn't accurately describe the danger.
The danger is you're putting your hand right fucking back. It's just kind of
Right, the danger is yeah, it could now.
What do you?
Oh, okay.
Yeah. Saturdays.
Take a seat, folks.
Oh, yeah.
Yeah, I always say it, and I realize I suck.
I did like take out the squeeze, like, yeah, get it fully push it out, like, oh, yeah, like that.
Okay. Easy, I don't know.
So for those of you who might not have been here at the very beginning, what we do in the second round is we go through questions. Most people have been writing, taking notes, or have been taking notes on slide numbers and questions that are more technical. So we're gonna do that now. The way this will happen is we'll start at a section, so we'll start at air pressures comes up, and we just ask what the first number is, and what the next number is. Sometimes what ends up happening, we just go slide by slide. I'm gonna try to say that we should avoid that tonight. If you don't have a question, like after every question, we will ask what's the next slide, so we don't spend time just walking through slides. We have someone taking notes. Yes. And hey, sub team leads, if you haven't read the message that you are taking notes, you should make sure that you did the best right now. Huh? Yeah, I can Ryan take notes. I have all these too.
They're figuring that out right now, so maybe.
I did this. Isaac had a laptop out. Isaac is right.
And while we're taking a second, let's also remember to be courteous with our constructive criticism.
Okay, so a few things that I'm gonna say are generally anything stylistic we do not need to spend time on right now. Everyone would rather go home and pick out that the color was wrong. So if you have a stylistic change, it would be appreciated if you leave it on the slide as a comment. Garrett has one stylistic thing that I'll take for a second. Secondly, what Kathleen said, be nice. I'm kind of specifically looking at the older members here, people who have been in these folks' shoes. Because thank you for being here, thank you for providing your expertise, but also recognize that all of these people and you like as much as that at one point, and you go wrong. I'm gonna say to remember to be kind, because I know that sometimes we get caught up in, oh, it's wrong, and not recognizing that we are all starting at the level.
As a, to go off of that, also, for you guys, none of the comments that we make are personal attacks on you. They are just comments. We are not trying to be mean, even if it, might seem like that, we're a little.
Isaac, the only outlet in this entire room is right.
So Isaac sits in the front. I would also like to.
That was next month.
Isaac, you're jumping off the aisle.
One comment that's supposed to be mean.
The screen, Isaac. I want to give another round of applause to all the leagues that have spent hours and hours and hours working on this.
Number.
8.
Alright.
Oh, sorry, yes, Gary.
Okay. Yes, so, a whole bunch of the like subtitle slides don't have numbers, it's like they don't have content, but if we wanna say like, I wanna go to the section about this, I don't know what number that is. So like, do that for the next one, and then real comment on this slide. There's a whole bunch of stuff that like isn't in plane with anything, like the bins aren't in plane with the slide. That you both looks to be at just some angle, like it doesn't really look like there's any specific blocking, which I don't know if there is or isn't, but at least make the fences plain.
Isn't that called a preliminary design review?
That's fine.
8.
Anything for 8? 5, anything for 5?
There is.
4, 5.
Like, take it.
8.93 feet, maybe a few inches, that's enough that people can actually use. My other comment or comment later.
Yeah.
Maybe a question for Arlo. Is there enough space for recovery? Doesn't look like there's a ton of space.
There's plenty.
Okay.
I mean, those should be good.
So you want all of the unlabeled boxes are real quick or probably. Cool, ready? Notice one tip, Credit Rock, eBay, bulkhead parachutes. The big one is the U-bolt, so that I can see like where it is. This is the upper camera eBay. Measurements, payload, forward closure, and the bolt that goes inside of it, forward closure is in motor for some reason. And then centering rings, lower camera eBay, centering ring, interface centering ring. Yes.
Also, the drogue this year is in the D bag in a separate little compartment. So if you just imagine the D bag that we had last year a little bit bigger, then that's how much space it's gonna hit.
Fantastic.
I'm just realizing pointing things out. It doesn't look like you have like a plus slip there. Just double check that if some.
It doesn't show the extra house. It says an extra half inch brush, but it goes right there. I picked the sizing and everything. Yes.
For your fins. 6 inches from where? From the.
Yeah.
Okay.
Yeah, like you put in 6 into a rocket.
Yes.
The parachutes should be all the way down as far as the slide, because that's where they're gonna be for the entirety of flight, where their mass actually matters for something.
Huh?
So that will affect your stability.
In our case, I don't think so, because our like attendee and stuff hold it up against that.
Yeah, no, it's all gonna be pressed up against the upper bulkhead.
Oh yeah, our drone's in there too, right?
Yeah.
Okay.
Cool. Anything else?
I'll make my drone, we make a different one.
How much space is there from the front end, from front tip of the fin to the end of the conical piece?
Yeah.
No, from the front edge to when it becomes perfectly smooth.
Oh, I know, this.
Yeah.
Right here.
I think it's 0.25. And then it's 0.5 inches. Anything else? 6. 8. Yes.
Okay, so the nose cone coupler stays as part of the body too, right?
Yes.
So I think the diameter might be a little bit weird when you shove the measurements eBay and the payload, like the bulkhead, that diameter, I think it's too small to run up against the body too.
This, the payload coupler, because the nose cone coupler can go in after make some payload going.
It's really bolted.
It's really bolted with.
Oh.
So it's very, we are gonna slide measurements, payload, and that bulkhead all in is one, and then we can slide all this as long as this is a protection bulkhead, but that's also how the nose cone cover is bolted. So it can go in often.
That's not from.
No. Cool. 8.
Your boat tail says 3 layers, is that correct?
Yes.
Are you sure?
Yeah.
Because the one last year was 6 layers.
Remember which one was first?
No, it was 6.
Event horizon?
Oh, 2 years.
Oh,
Remember
2 years
was
ago. Okay. Because the testing we did last year was 6, and it also reflects the same thickness, I believe.
Yeah, the thickness is it's thinner than last year. It's 0.1, right? Yeah.
Based off measuring it.
Huh?
Based off measuring the horizon.
We measured.
We did, it was a lot thinner than that.
Oh,
I think 0.1 was when we were planning on 4 layers.
oh, then that should be 4 layers, I believe. We'll double check that. It's
Okay.
thinner than last year.
Event horizon was 3 layers and like 65 or 70 thou. So 4 layers will put you around.
Okay, so 4 layers is fine.
Your reasoning for the ion being steel is also, it needs to be because of the defect.
Yeah,
The defect said make everything recovery steel.
yeah, that is actually not good enough, so.
Yeah.
Edit.
Generally effective in packs, but also like I'd say for some of the material selections like PET-G, you care more about like why PET-G than
Right,
like it could be steel, but it also could be PLA.
right.
So why?
It's strong.
Then that's
But yeah, right, sorry,
Also, I think with PETG, big reason is, temperature, it's on saturation, we want to melt.
It is strongly relevant temperatures.
Yeah.
Cool.
Wait, Chris,
Yeah, for the nose cone tip, are you gonna have the threads in that also be at manufacturer, or is it just gonna be the outer profile?
The threads.
Leave it.
When I sent the photo over to photo space, they had.
Okay.
I was just bang the drum again, all your thing about strength there. Fiberglass would also work for that.
But it's low weight
I mean,
and it's high.
I just want to reinforce those, no,
Low weight and high.
So you shield, shoot that.
Okay, next slide.
next slide. What? Are all bulkheads 70-75 except for the nose cone bag?
Yes.
Okay, so. Can you go back to the rocket?
So yeah. 661. 70-75. 70-75. 70-75. 60-61. I believe Brian. Is this one 60-61? I can't remember. Yeah, that's what I'm 661, 661, 61, 725.
Have you done, it doesn't seem like you've done FBA.
We haven't, like, we've done preliminary FDA, just like checking everything's good. We'll present FDA.
And 60-61 did not work.
70-75 gives us, we're gonna say, like, we're gonna rerun FDA and like double check, like, specifically. 775 to use for now because it has a high weight ratio. So especially with everything above the CG. We want less weight, but we're gonna rerun FDA with both, like, do better comparison to that.
You can get 60-61 instead of 70-75. It's cheaper and it.
But we would probably need more of it, but we'll see.
Yeah.
We'll do like cost comparison and also everything, yeah. We were gonna look into that further, this for now, because that's really.
What are the balls?
Oh,
Yeah, I was gonna, they're like, they would be like, if they're gonna get patches.
So column slope tube versus.
I was just gonna say about 60-61, like, the main issue, the reason why we switched over was because we had too much weight on top, it was actually too stable, so then we're like, that's why.
You don't need like fixture.
That's why I'll do that.
Yeah. Okay, next slide. Oh, Olive.
Zoe has a question.
No, it was first. Oh, it's the one, so instead of being a circle, they look like a little teardrop. We'll get later, but instead of being a circle, it's like a teardrop shape. So if you think about drag, it's gonna be better if it's like teardrop and it's just hitting a circle. Yeah, they look cool. And we're gonna do they reduce drag. And then you like sand the edges so that it's like curved, instead of like boxy. Anyway. Next slide. 11. Go.
I personally was here, but I don't remember seeing anywhere in this presentation how recovery is actually packed.
Arlo, you can give a 2-minute, like, you have an idea of how it was.
Yeah, it was in PDR, but someone called it just a bunch of blobs. So, it's debag. The debag will have two. It'll be like a main debag with an extra little bit of Kevlar on it to house the drogue, just so that we don't have the problem of something we wrap in a fire blanket is just going to jiggle out and get blown up. So debag but bigger. That's how.
Hey. Anything else inside of that? As well? Well.
I add a top view of how, how interfaces, because like you said, it's hard to describe. You add a top view to describe it.
Just like show CAD.
Yeah.
Yeah. The black boxes in CAD and the back, you probably always have to do this have to show the routes, but yeah.
Yeah.
I get the vision and stuff.
Like you say that the payload right here is at like the 90, 180.
Yeah, so like
So
a
you
quarter
could
of
show those. You could show those kind of bots like further out because otherwise it's like at the 45 the payload touching the walls. So those kind of bots should really be like on the
Okay,
walls.
I have a question. Are the threaded routes going install?
No, I didn't say that. No.
Yeah.
Okay,
Better
better diagram.
cadence those.
Next slide.
More of the same.
13.
Only 3 volts.
Yeah.
Okay.
Did analysis, trying to weird spreadsheet.
Yeah.
This is the time to show the calculations you did for all your decisions.
I didn't, more of a video thing.
That's my little.
That was, we just kind of did preliminary, 3 volts, we should now look more into out the video.
That's also fine.
Even if you don't show the math, if you have, even if you if you figure out a reason for there to be 3 volts, tell us what volts there are. Because I assume then you decided on what volts they are. And don't say what volts.
Yeah, okay. I don't know if that was more of a choice, but that's fine. I will say right now, everything that connects to the airframe is technically.
It's fine if you haven't done the math and just say it's molded, but if you have done the math, you might as well tell us what molded back.
Okay.
Say like the map for this is on slide whatever where all your other full map is.
Okay.
Then the like a layer section has like 3 different ones of map, like throw it and just say it on a different slide.
Okay. Next slide.
Next slide.
Oh, well, okay.
What is the connection between the thrust transfer bulkhead, like the actual bulkhead and the tubes?
It's variable. Yeah, so I realized I didn't put that in. Anything else? Okay, next slide.
How much spacing is there between the?
Any?
Yeah.
Half inch?
How much thread is there?
I believe also half an inch. Don't quote me on that, but I believe.
And I assume we're not gonna do any it's maybe a bolt of that location that's gonna on the lock type. Like I have no issue with that, just making sure that.
Yeah. Cool. Next slide. Anything before that?
I have something for fishing. Oh, so like, you shouldn't really have the bottom horizontal arrow, like it's going straight out. Just like brush strokes are fully going.
Okay,
Because the way the thrust is.
yeah, good one. Okay, 17?
My third comment is just your tolerance on that note is interesting. Whatever. And then the other thing is, so you picked a von Karman 5-1. Why? Why that over anything else?
We looked at papers, like old, like studies, and studies, whatever. There's some graphs somewhere that like compares all the different types of nose shapes, right? Auto power series, wonderful for some reason, uncommon, and the supersonic flight, uncommon is the best, and also the best around transonic and.
Seeing that graph would be spectacular.
Okay. And put that in. The other thing I did is I just went to Rise Arrow and put different objects in, and basically I go to high speed.
Graphs of those would be great.
Okay.
This is the time to show you.
Did you also experiment with different length to diameter ratios?
Not as much, so I could do that.
That'd be a good thing.
Does the 30 inches include the nose cone tip? Does it also include the 6 inches? How much?
It
What
includes,
is
it's here to the nose tip.
the nose cone tip?
Yes.
Is that paper living in the drive for like next year's leads?
It's in a research document. Oh,
We're doing a clocking notch for the nose cone bulkhead.
yes.
Okay.
Is that, I don't see anything for July.
There is not a clocking up in the UA volcanic yet. There will be, so there will.
Who's taking notes for all this stuff? So
Oh. Anything else on this slide? Next slide. Oh, next slide.
Is there anything for these slides that you just brought them straight in the last time? Yes, there will be some set inserts. Write that down. Okay, so you don't have like nuts or bolts or things.
You said at the start you had like 20 different problems with this email or something.
There are notes that I'd like to implement too for a future design. That's correct.
Can you say
Yeah.
what both problems you've had with this as well as what you plan on continuing on the email?
Okay, now that we've sort of finalized what components are going in, it's still a little bit figuring out intelligent guess and whatnot, but I wanna confirm with avionics where all the ports are and what directions they face. Last year we had an issue where like one of the flight computers, we had to like disengage it from the sled to like plug it into a computer, and I wanna make sure we don't have those issues. Same thing goes for cable wire management grommet things. Those are where they are for now. They do not live there. I want to reposition them so I can route wires correctly. We have to add a Siren antenna to that face, that's just to the left of Siren on the leftmost image. Right now, there's just 2 cable wire management things because I want to zip tie that, but we don't know what the antenna is just yet, and we have some other frequency issues that I'll get to later. Nuts, bolts, holes, and heat set inserts still have to be added. So to say clocking notch, that was very important. That's my bad. In the middle image, there's the Elvin beacon and the maybe I'll play computer. GPS. Both of those antennas as well default run on the 440 megahertz band, which is not ideal, and we are going to work that out because that's a concern. Serena told me about a timing thing about when it could send packets of information. I think the plan is just to have 3 flight computers, three antennas, 2 of which will run on the same frequency, 1 will run on a different frequency, and then the 2 that run on the same frequency will alternate in terms of the time at which they send information. Screw switch covers have to be added. Those were super cool last year. I did have a question. So regarding the rightmost image, that's the battery cover. this is like, this is something I did at like 1 in the morning, and I'd like some advice regarding it. I think I can make it one piece. Gordon suggested making it one piece within the slot, so you could like slide it through the threaded rod and then into the eBay. I think that's a great idea. Gordon also said one bolt like totally work because the pins themselves would be like locking. I'm a tiny little bit uncomfortable with that, but if you'll
Because it's positioned by those little posts and held down by it.
That's so true. Yeah, you don't need that on some. Well, that would be so cool. All right, guys, write that down. I was wondering if anyone would have any recommendations on the distance that I should have between the top of the battery and the bottom of the pin, because as of right now, they're like the holes in the eBay sled for like wires to run through. They're a little bit bigger than I want, but that's mostly so it's very easy to put like a pair of like tweezers or something through to pull out the wire. Those have to be there because the wires the batteries have are not super long, so they can't go out the top and all the way down to the flight computers. So they pop out of the middle of the eBay and then they can be routed up or down. That's why those holes have to be there. Yes.
I want this one. Yeah, if that's the case, is there enough space for the battery and the connector for that battery to squeeze down there at the same time? Because those holes look like they're below the top of the battery, am I correct? Like those holes on the side are below the top of the battery?
No, sorry. Those are at the bottom of the battery. Like where they're the little house looking thing. The bottom of that is where that like hole ends. If you're like looking down at it.
Okay, I would maybe appreciate a cross section.
I'm gonna table this and people who have some ideas about it to talk about it.
I do have an. Is there a mechanism to stop that print, like that whole big print from spinning?
There will be set inserts in the bottom that'll be bolted to the
Okay.
plate.
See, Ryan, this is how you say, there will be instead of there are.
Yeah. Then I have to tell the truth, and that's lame.
Guys, I suck. I'm sorry.
Okay, great.
Next slide.
And two.
21. Is the velocity component like purely horizontal? It seems like a lot of the velocity. Is that just like what Open Rocket does? Okay, just is it purely horizontal?
Well, yeah, cause a lot like. Yeah. Well, you can see the breakdown right there.
Yeah.
I can't go here, but that number that I love, like.
Oh, okay.
In the
So,
future,
yes.
you might want to include because Razer will give you the table of numbers of vertical, vertical velocity and horizontal, and you should press the top. Yeah. Or just tell them.
Have this later, but in the like, requirements thing, but 164 feet per second is really close to 165, which is your like requirement. So
That is not factoring in the fact that there is the rocket has drag. So it'll, if anything, it'll be lower than that. Two, I could go to 26 inches, which would make my life easier, but we would drift a hell of a lot more.
We were bouncing back and forth, because originally, 2 or 3 days ago, we were looking at the compliance matrix and we were, like 160.
171.
Higher than that, so we just barely managed it.
Do we know that drove velocity requirement is for the entire drove descent or just at main deployment?
Later in the compliance matrix, I'm sick of that, but I believe it's for the entire.
Yeah. I'll figure it out, but I believe it's the entire descent.
21 and 22. Arlo, is this the good material that works with the drag knife?
Great.
You mentioned about the drifting. Do we have like a number for how far we're expecting to drift, given like COVID?
No, because I haven't gotten any wind. I just looked up like what is like what will they allow? What is the maximum wind they will allow us to do? And then just kind of went, that's a really big number. I don't like that. I don't want to drive that far. Which is the thing.
Drift analysis for CDR.
We can't, I mean, well, you can assume worst case of what's the like,
Yeah.
what's the biggest angle that they'll allow us, and then we get to whatever max altitude, and then wind is all in that direction.
Yeah. The main issue I had going from 25 to 26 was the the velocity at main deployment changed so much that we would not only would we be drifting more, we'd also just be like hanging out in the air for like way longer than we should.
Think about 22.
I think about, yeah, I think about 22 is the just saying. Also, I'm assuming this. So I'm assuming this deploys at 1,500 feet.
Oh, yeah, I think that.
But it's in Connaught, so. I would think Connaught should be.
Yeah. 27 feet per second, is that comparable to what we've done in the past?
Yep.
Okay.
But if Event Horizon like actually hit it like 30 and was completely fine.
He takes 36.
Yeah.
Well, the part that.
Well, the part that I 30s. Part that
Next slide.
23. For thing where you list like the max capacity for like, okay, it withstands 3,600 pounds. I think you want to also include like, based on what we actually expected to experience, here's our backup safety.
We don't know that yet because we don't know what the shock factor is. Right now it's just yes, but
We couldn't get a hard.
it's anywhere between 2 and 7.
Oh.
Zero.
Well, state that, but include it in the slide, I think, so that instead of me being like, is that safe or not?
Yeah, shock factor, Matt. For testing, I don't know how.
Ow!
You gotta
Hey, any new people looking for a good project? Help Arlo with that.
Yeah.
Yeah, next slide. Oh yeah, do we have an idea of number and size of shear pins yet?
No, we haven't done any of that, yeah, because we don't have. We just know what they're getting.
Next slide. You're not gonna get parachutes yet done this year, it's just like.
We can try.
We can try, but. Like,
The CFD is not as critical to IREC as the drop test. The CFD is informed by the drop test because the drop test does different inflation amounts. So we have a plan to do it, and Chris is going to help out with that, but it's not like super critical at the moment.
Do you have a general timeline for when you expect much of this to be done? Like,
Well, this green's already, well, all the greens already done. This, the recovery line parachute connection train test is kind of dependent on rock schedule and when you allow the students went in.
You said that would be a while.
Yeah,
And then funny story, I was supposed to meet with VTOL about 50 minutes ago. Forgot. Okay, well,
Next slide.
Next slide.
Put this in the paper. I feel like the judges are gonna really
Oh, yeah.
like,
Arthur said it to me on the walk back, yeah.
yeah, put this in the paper.
Well, no, actually, I was gonna say, I'll write this stuff up now, so that when it comes time for writing paper, you're not like, oh god, what did I do, like, write it down.
try to get the next like 3 weeks of exams.
Roll.
Great.
Do it right now.
If you started.
You taking the joke, sorry.
Okay, next.
No,
Anything? Oh, sorry.
I don't know exactly how the setup for this test works, but if we could just pull on a piece of line and actually verify that 3,600 pounds, that would be.
Yeah.
That did not go according to plan.
That's what I was trying to say, like, it's hard to see in this picture, but it was, the Kevlar was rubbing up against an edge on the plant, and that was causing it to break at 1200. And then the one where it was sewn, where it was like not having that issue because it was wrapped around a rod. That one was 3200, so I think, like,
Yeah, you'll be fine.
yeah, we're gonna,
It'll be great, verify that number.
yeah, I think, like, we're close enough to the point where, like, a lot of these numbers.
So 200 is also gonna be completely fine, unless the dog factor was 70.
Then, no.
That's
Slide.
28.
Okay.
28.
Now we hear the
Oh, yeah.
rail buttons.
Is it safe to sand them?
They recommend you do it.
Okay.
It's going.
Okay,
That part of the also takes like no force at all.
yeah, that's what
Yeah,
I
so you're setting the part that doesn't.
okay.
Yeah, practically you at like 51%.
You wanna make sure that before we build the like test launch or whatever, that we put this on rail in the bay and make sure those are lined up since they're not symmetric, because yeah, otherwise I just know what like these off, just never getting on.
Yeah, I would say there should be some like actual specific plan about how to make sure these stay like
Aligned.
vertical.
I mean, I think they'll stay vertical once we get them vertical, but like, let's check it before we go out.
Yeah.
Have a segment of rail that's like just longer than that, so it's not unwieldy that we're
We
getting.
have trail.
Yeah. And then also, I think it's clearer later on, but I'm pretty sure you have those teardrops facing the wrong way in the cab right now.
Yeah.
Right.
You have the pointy side up.
You can see one down here.
No,
Yeah, it should be pointy side.
It's on your side now.
Yeah.
Ouch.
Oh, yeah.
What's the plan for the lower interface voltage? We talked about that a lot, like at top of like changing that, like how many volts essentially.
Right now, the plan is 1, 2, 3 volts around, and then there's like a set volts on either side of the shot, and
We determined last year that we OTP something to clock it, but most actually don't do anything useful.
It seems a little sketchy just from like a joint stiffness thing. Especially if all the aerodynamic load of the fins is like right there. Like theoretically, sure, but it would be nice having bolts there.
Is your interface bulkhead thicker? Like that one?
So yeah, that was good.
Oh, I was thinking, it's gonna have to be much more
what's
efficient.
the plan? Because we were overstated, so
Should make your fins go.
I do want to see an alpha.
It's at 10.5, you can make it 10.1.
No, it went down below 10, so we all looked like anyway, so. The best solution that I had was to make this thicker, make these thicker, make these thicker, and then set the camera eBay is like kind of upside down to how it's showing.
You could also have 3 fins.
Devil's advocate, we try to drill holes correctly and we don't always do so. So some poor guy at comp is always filing the holes to be bigger and it like, gives him a heart attack every single time. But he's like filing through the body. Wire holes still like at the end of the tube. They could totally
Put them in the middle and give yourself some factor safety. I thought it was gonna be
Yes,
two centering rings that are both really thick. You don't really need two centering rings at that point.
yeah, but you
I
know,
think
wait.
that's maybe. We dabbled in, or well, I talked about making the boat tail thicker and it's farther away from the CC, but that's none of others.
Using the weight relief on the top. Instead of adding weight to the bottom. So consider, can you write that down? Consider weight relief on the top instead of adding.
Yeah.
weight to the bottom.
The brain wasn't good,
Yeah.
right?
If we goes 3 volt at the bottom, radial volt, make it 4 because you have 4 pins so that they can clock. Not in front of the leading edge of the pin.
Yeah, that's good.
Okay.
This is just a nitpick, but if there's any way to avoid having the rail button block off the thing on this, like the bolt on the below or above the thing where you screwed in. Because you know how previous years when we screwed in the rail button, you couldn't then screw in the bolt that was immediately below or above it. I don't know if that's fixable, but if it is. Yeah,
With a thick ass
Yeah.
ring like that, it's.
Still in the way, that's big, bro.
I didn't wanna say.
Speak up.
Ultimately, that might be an argument.
Size, I guess.
I had it relevant, I tried looking for CAD online, but I think they don't want people to 3D printing their relevant that you can buy. So I tried, because I went to buy them, I didn't make those for site, it doesn't be had. So the relevance he had were based on me trying to buy out of their picture.
But I'll give it to you, we can just put it on.
Ultimately, that might be an argument to like block those screws, like. 6 degrees off of the so you have 4, but there might be like 30 degrees on one side of the thing.
Yes, I have faith you guys can figure it out.
Sorry.
Ready? Oh,
Very brief comment on that one that I didn't get to. They say 67%. If we have time, we could also just run CFD, get somebody familiar with it on something simple if we want to. Yeah.
Great. Next.
Yeah, we can. Say what bolts you say what bolts you don't.
That. If you have actual factor of safety. Make them realistic. I don't think we know our factor of safety to. How many safety is that? Again. Round shit to like.
It's fine.
We have each factor of safety based on what forces and like, what calculations, what FEA. If you've done it, just show it.
If you have a number.
It specifically says bolt shear. Which probably need a limiter, but also if you have that bulk in your payload, you're gonna have a whole bunch of torque yanking on it if you hit the ground sideways. Like also account for that, cause that's gonna be.
That's a lot more. based on
But the
structure than
corner of
payload,
the
which is why we cannot calculate it.
What?
You're at the corner of the
They
panel.
don't touch the tube.
I know, but I think it's gonna hit the tube.
I think we also don't want it to hit the tube and put a hole in the
It
tube.
looked at ballistically last year and was completely fine.
If we're doing the analysis, we need to do it right.
Okay, yeah, let's, to Ryan's point, that's based on the structure of the payload, which means.
So, so but it is able to be done by the time CDR communication.
Yes.
Yeah.
Next slide.
Why do we have 2 cameras?
To see more stuff and because we can.
Isn't the one in the upper up?
Yeah.
It's looking up.
We operate up the chute and the one looking out the permit.
Like,
So that's a much better answer than because we can.
yeah.
Also, we have 2 camera eBays, we actually have 5 cameras.
Now it's still better than
Be quiet, it's down kind of separate,
No, I
like.
know.
Good.
So the upper camera eBay, that is where parachutes and whatever are, right? And that's near the separation point? Yes?
Yeah.
Are we at all concerned about when charges go off covering the cameras?
Yeah, right here.
Same in the presentation.
Talk about the way
That's a different, he's mentioning a different thing than the
Covering the camera.
test.
Wait, that's the last step of the ejection, or the.
That's to see if the camera shields don't just, you know,
Blow up.
delete themselves.
I'm saying.
You can test
Well,
both that one.
Okay, that's true, okay, fine. I'm saying that if you're covering the camera shield with residue, you can't see anything through the camera.
Oh.
If you have like a piece of tape or something that's secured to any part of the recovery line, so that it gets pulled off of the camera shield.
Sounds like a great way to lay a piece of tape over it.
That's exactly what's going on.
Next comment.
That's,
Yeah, okay,
Listen, I have no.
question. Number one, let me do this one first. Why are these only 30 frames a second, but the other ones are 60? Why are they only 1080? Like, why do we choose these numbers?
Well, it's just a different camera for this one.
Okay, but why did we choose
Different cameras.
or just the resolution and frame rate that we chose? Because I'm pretty sure we could get better in that form, in the size we have if we really wanted to.
Not really. So the lower one is around the motor, so it needs to fit in that space. The 4K ones I could find either didn't fit or had too much current draw to use like a reasonable number of batteries, or both, usually both. These also do not. The upper camera eBay SQ11s do not fit around the motor, which is why they're not fit down there. They're more thermally resilient, so they don't need fans, which is nice because space is a little more constrained for the upper eBay.
Any analysis on that at all?
No. So
That for CDR.
you can't really analyze it. I'm just gonna buy them and print it and like put them in an oven and see what happens.
Keep their making.
Oh.
Make a decent estimate of how hot the inside of the tube is gonna be.
Yeah, but I don't know what temperature they stop working at.
Well, they say 140, so
Yeah,
think about
for these, not the other.
Okay, well, yeah, but you can do it for both of them. Both the other one should also have a temperature rating. You can do
They don't.
some.
You would hope.
Okay, well, then test that. But you can also do analysis on how hot it'll actually get inside that tube
Yeah.
with how much power they consume and sun and whatever.
It'd be great to have just like a little picture of what they look like.
Oh, that's fair.
Yeah.
They're cubes.
Here, did you get the second?
No, the second thing was about the temperature.
Oh, right.
Yep. How do we turn them on? These use less current, so they'll just be turned on when you get them, like put them in
The whole time?
Yeah,
13 hours.
Is the requirement 14 hours from what other people said?
I assumed that was for mission critical.
Yeah.
Like, you know?
Yeah.
Oh my god.
These cameras fail.
Yeah, no, it's a good question.
It's
You're also running out of storage before
Oh,
battery.
I forgot to update that, my bad. Ryan made it work was like half a terabyte. We're chilling.
Yeah, you can just get those.
Plus, this is not worth it. It's actually 10 gigabytes. So we can.
Yeah, I mean, the birds aren't that expensive. We can just get bigger ones.
Exactly. It's officially saying you can't use those, but you totally can.
Alright. Wait, how would you manufacture the like cube with 6061? Would it just be like 4 plates that are bolted?
It'll be the payload, basically. I'm gonna steal your shit.
Okay.
You mentioned something about active cooling.
Oh, so the current plan. You have your camera here and the battery and love converter power, or that'd be a boost converter, I guess. This is just a fan that's like directly on it. So not really active cooling. This is plan A. If it doesn't work, we're gonna have some like LK coolers up here. Really would prefer not to do that. That's pain. Yeah,
You
the
could go
code.
cold side, so fine. Your hot side is gonna be really hot.
Yeah, and then also battery and boost converter for the fan.
So realistically, do you have a plan B?
Yeah, okay, so.
Even though you guys said that's not gonna work.
They told me.
They could be made to. The current design would not work, because I really know how they work. But they could be made to work.
Alternative is fuck ass, but not like broken.
Correct. Yeah.
Okay.
Also, you have active cooling, you have a fan that is active, you have active cooling.
Oh, dope, okay.
Yeah.
Like,
Can we go back to 35 real quick?
Yeah, sorry, I jumped everybody's screen choice.
Yeah, okay, so you have is there any reason your fans just aren't always on? Like every time it goes on the pad, if
Yeah,
We're also, we're not turning on the cameras on the pad.
Yes, we are.
They don't say that.
So they won't be using the screw switch, but they will have a button to turn.
Just gonna hold your both buttons.
Yes.
Okay.
So these like kind of need to be turned on the pad. The fans kind of don't, based on running time.
Okay, well, if you turn the cameras on the pad, you can turn those fans on the pad, but. I mean, if you find the runtime on that is gonna be 17 and a half hours, it's also not necessary.
Yeah. So is the
that's
screw
what
switch-
is easier.
So the screw switch to turn on the boost converters?
Like I've been assuming that just once the other parts of the circuit are on, the boost converter will just.
So I'm just saying, what are the screw switches turning on then if they're not turning on?
The fans.
The fans.
Oh, they are, okay, yeah.
Your voltage converters also take like basically no power if they're not outputting power.
Yeah, there's just like an efficiency that isn't 100%, and that's it.
Oh yeah, they have a passive draw of like, and then an efficiency of pretty good.
General thing with screw switches, you need to know that they are turned on when they're, once you turned on the screw switch.
Like have a feedback.
Yeah, have a feedback. Yeah, add an LED or add something to this, because once one fan is on, you're not, or once two fans are on, you're not gonna be able to hear the difference between two.
Also, depending on how big your fans are, you might just not be able to hear at all.
Yeah, so, for other eBays, yes, some things have beep codes. If you don't have a beep code, definitely you need definitely you need some LED, you need some sound, something, so that from the outside you can tell that the component or the circuit is.
Some flight computers will just have that, but like none of this stuff does, so.
This is actually a bit past electronics, but the camera eBay in general, is that, except for the camera, is that fully contained within the outer body? Was there a break in the body tube for where this whole camera setup?
No, it just slides into the body too.
Okay, and then the little covers go on after it's in the body tube?
Yeah.
Okay. This that'll be the order, you slide it in without the covers, there's holes in the body tube where the covers go, then you attach the covers. And then it's, like, once the covers are attached, you couldn't, like, you couldn't slide it out that way.
Yes, once the covers are attached, they could not slide out, which is why they're bolted and not adhesive.
Oh, next slide.
Yeah, no, next slide. Is there, are you just gonna be blowing the hot air around inside that, or is there like a fan?
There will be a number of holes, just like for the screw switches and turning stuff on. I might also have a dedicated like intake hole basically, so the fan can draw in outside air to blow.
From a different section.
Yeah.
They're just like from the trunk of tube above or below.
Yeah, but that's also inside the rocket, like, I think your point is more access the outside air.
Yeah, if you have a box with a fan in it, it's sealed, it doesn't really do anything.
Yeah, it will delay your camera. Okay, but it won't.
Well, if the issue is heat accumulation in the camera, it could still help, but also there will be a bunch of holes poked in the wall, so. They should have enough.
I think that sounds like something we should just bake in there, see this.
That is the.
Can you describe how the motor tube is gonna be attached to this?
Yes, so on the bottom of this, you will have brackets bolted in. That is a voltage connection bracket to this.
So you have a better view of the.
Yeah.
Next slide.
Yeah. Bolted here. So multiple of those, and then that surface area is just epoxy 2D mode. Some plastic fiberglass bonds are not great. This will be ABS, which bonds better.
Next slide.
So if you're doing active cooling of Peltier, it's the same thing as the other, like just a fan. Where is that heat going? How are you getting?
Yeah, I talked to Ryan about that.
Okay.
It'll be a heat sink on top of the Peltier and then also a fan for the Peltier to remove the heat from it, get it off it, and then either there will be holes in that section of body tube above for other purposes, Or there might just be holes for the sake of, venting.
Also increase your total by. Make sure you roll that few things.
Okay, cool, next slide.
41.
41, anything for 41?
What did you say? There's
39.
How big are these cutouts for the wires? Do we know how big the wires that we have are?
Yeah, they're, I looked at this one, they are a 1/4 inch by 1/4 inch, which is fine,
Yeah.
correct? Okay, cool.
It looks like
The ones in the,
Yeah,
the ones in the center rings and stuff, 0.5 diameter, but could we make those smaller?
I think so, it just depends on what wires are using.
Okay, so yeah, pending.
Remember, it also depends on the connector on the end of the wire that we hit.
Yeah, you did with the connector.
It almost.
Yeah.
Just make sure you double check that before start.
Yeah. Okay, next slide.
Just,
Thanks, Ryan.
you can see, yeah.
31?
This is the talk about the rail button.
Yeah, blocking the zero button.
Yeah.
That's right, that's.
Anything else?
I can also align the pin, how long, so.
Okay, next slide.
44.
44?
What orientation of the fibers came to that specimen?
they will be run like that and like that.
Okay.
When we did the layups, it's like, we do that specifically for that.
Yeah, or the test specimen, I'm asking, just like what specimen. That makes sense.
Cool. Next slide. 48?
46. Your numbers. Your numbers are not what they are.
2, 5,
No. Well, that knows, but also your average is not
Oh,
30,000 feet.
okay, yeah.
I don't know if your times are correct,
The times I did check.
and I don't know if your motor burnouts. Motor burnout being an exact 8,000 seems.
But we can, so.
I mean, since it's about that.
Yes, actually.
Huh?
Your comment about sync things. Yeah.
I said
Just
it's
say approximately 8,000.
Okay, cool.
My comment is just this should be.
Okay, yeah.
Actually, that's first.
Okay.
Anybody have anything for Sam?
48 was that one?
Good job with conversion stuff.
Yeah.
That, yeah.
Is 31.3 like with any ballast or anything?
No ballots.
If you don't count the, temporary center.
I think I want to see stability with wind and without wind.
Okay.
I usually grad is the weird.
Wind's gonna be worse. Isn't just wind is gonna be worse.
Yeah.
Partially.
Yeah, it'd be good to see.
Part of the reason we were overstable is because Rob and I were originally simulating with wind, and they came out, it's like, no wind, so that.
And then DTO was kind of.
For our internal purposes, we want it to
Yeah.
be able when there's wind.
Yeah.
Like, if this is the number IREC wants, that's great.
But
We
we
as
are-
a team should care about wind impacts.
Yeah. Olive?
Is the plan for us to fuck up manufacturing that it brings our apogee down by?
No, but the plan is to have enough wiggle.
Guys, I will say, as IREC lead, I would rather our rocket go 33,000 feet than it go to 24. I am going to be happy if we aim for 33,000 feet, because A, either we fuck up shit, or B, we go to 33,000 feet, and at least when people walk by and see that rocket, we can say, hey, we went to 33,000 feet, and we prove that we can actually do that.
And then we can have every back.
So this year, we're getting past 30,000, or at least to 30,000. Next year, you can make it better.
Next year,
Comment on the slide.
Show me acceleration in B's.
Okay,
Yeah.
good point.
It's just a nicer number.
Yeah, you,
In this case, from the graphs, off the run stability is our minimum stability, but specify what our minimum stability is, because sometimes it's not off the run stability.
might say that, huh?
You said that, that's right.
Sometimes
You
you
did
can
it.
sign
Yeah. It goes up and then it comes back down.
Did it shit down?
It
Yeah.
depends on how big your motor is and.
Okay.
Yeah, it's just stuff, but it does happen sometimes.
I'll specify that. Anything else on the slide? Cool, next slide, number.
Next slide. You would, so is there wind in this?
Yes.
How much?
Netherlands is 11.4 with 10 deviation.
Know that number.
Cool. Well, we can do the then.
OER
Yeah.
parameter.
For what units, cause there's a few that could be.
Not per hour.
Here's
Okay.
a second.
I was thinking it is,
Okay.
Just
So we
show-
can- yeah.
show all your simulation parameters.
Yeah. Cool. Next
I
slide.
want to see simulation parameters for this.
Yeah. Next slide. Number 4.
One. Did you have a open market stability?
No, we can add that too.
Got it.
For when, yeah. The same comment, so it's just having. So yeah.
You have your semi-span as 6 point something.
8 to 8.
Does having a larger semi-span make your flutter better or worse?
Me too. Worse.
Okay. So this is your worst case measurement?
Why'd you pick that for the material?
Because it's the worst case, so I mentioned this, but there's 2 different CF compound plastic options in sim. We just pick whichever, we look at both, pick whichever one goes to the worst number. And I said once we have testing of the shear modulus, we can make worst material.
Did you test with the old material as well as like a fallback in the event that all of your planning ends up falling through?
What do you?
Like the past several years we have used, or several years to my understanding, we've used fiberglass sheet, carbon. And we've done like 7 mil fiberglass for testing. Did you do running of that simulation?
Well, I assume you also shows anymore.
Yeah, and this is always just the worst. We don't know.
Is this worse than your fallback? Is my question.
What are you talking about? You always.
This is
No,
This is
no,
a different material than what we.
that's, yeah.
Well, if this is the number that gave the worst, this is what we should have.
But I
Is it the worst overall or
I
is it the
don't
worst
No,
of the two?
it was.
Okay, so then double check that it's the
Neither-
worst overall.
Yeah, there are other than, we use something that is not the two that carbon fiber.
Yeah, we did like 7 mil fiberglass.
It was 7 or 5.
Yeah, we just.
You can double check it in the old like.
It's in the mail something.
Okay, sorry, I thought I did, but. Yeah,
No, I forgot it.
cool. Next slide.
56. How did you calculate that CG?
The thin CG calculator that
Don't-
we've been using.
Don't use that, or because it assumes a perfectly flat, like, root chord.
Okay,
So
I can use.
use dollar CG.
56?
I got 56.
Yes.
Graph, please.
50 minutes.
Hey, I already
Just. Or, oh, sorry, no, not graph, like a diagram, like. It might be better if you can show what CN
Okay,
actually
yeah.
is, like you can show the arrows.
Your definition of CN alpha, it includes CN alpha, the
Yeah.
first bullet point.
It would be, it's a lot of CN versus.
Versus.
It's good.
Yeah,
First, you get the damping ratio and like natural frequency compared to roll rates would also be good.
anything else? Cool, next slide. Wait, number?
Brian said that, like, bring it down, but like, if our minimum is 10 and we're at 10.4.
No, we're not. No, we're not, we're something else.
4 or 5.
Is that, have never done analysis with this, but is that feels too low compared to.
10 is like the actual minimum. It's not like, oh, minimum 10, so make it 20. It's like actually 10. So I'm like some NACA paper from the board and that just.
Don't we have a good source for it? It's
We
not
also
just
have
not
no
every
every
other
other person
person
who has ever done this analysis.
Okay.
Like every person who does this analysis does something.
Okay.
So
Cool.
my friend told me to jump off a bridge, like I'm gonna do it too. I'm doing the issue with this, like. Yes. Then next one.
Oh,
What specifically does this tell us?
this tells us where Rex Q occurs, like timing and stuff, it's used for, and flutter. And then the graph is just nice to see, like a good sanity check, like nothing really.
It's gonna be nice to compare to like event horizon work that it had a dynamic pressure of X.
Okay.
Didn't. it had this,
Yeah.
but yeah, this is good. So.
I will say I don't know pressure in 4 kilopascals above Helios. I tell you that.
I think the time is kind of misses out on 50 seconds.
Okay.
Yeah.
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 Okay, cool.
That
No,
lies.
that's fair.
Well, 50 seconds also after
Wait.
altitude.
Oh, yeah.
Why is this after altitude?
Yes.
Dynamic pressure versus the altitude feet.
Wait, yeah,
That scaling is wrong.
That's, yeah.
I'm have
I'll
a
grab them in Python next time.
hunch that it's times.
I'll grab them in Python
We
next
got to
time.
keep the pressure at like 45 feet.
Well, the 49 through so times times.
Yeah, I'll grab them in Python next time. Next slide.
60.
60.
That CAD looks familiar.
Hey. Brand new CAD. It's just very inspired.
Oh, okay.
No, it is all like positive.
They don't want your work to go to waste.
Wait, so is this new work? or
Yeah.
is it-
Why?
Exactly.
Yeah, eventually. Oh, Jake left, but Jake did a lot of it.
But why?
Yeah, why?
Was it to teach a
Is it like different?
Well, to teach, it's like a good practice for the freshman to so that they understand, they know what they're doing. Also they do it differently.
Okay.
And the caps are there.
So,
What's up?
So yes, there are differences from last year. Okay.
Yeah. Look.
Clearance are the have top 2 credit rods have with the.
Half an inch above, but don't quote me on that.
I feel like I should. Like it should be your job to.
It's mostly back purposes, whatever it was last year.
Okay.
So
There is clearance between the top of those credit rods and the crossbar.
Yeah, they're not flush.
yeah.
Okay.
Yeah.
I could not.
I'll double check.
That art show.
Yeah.
Yeah, there'll be enough on them, but they won't go past it. Right.
Anyway.
PR, that's not a PR.
What I should do is make Isaac, can you put in a make a low one for me? So, oh, Brian, he loves to make low one. Because I believe. Thanks. Yeah.
Yeah, so the third bullet point, is that implying that the thrust load goes through those threaded rods? Cause that's totally not right.
Yeah. That's what you.
Those threaded rods are like buckled immediately.
Yeah, it should be.
You know what?
So I was thinking
I
like
remember that, I would say, it is something, or the top of that there, not a couple of that. Yeah.
I also suspect you're putting a lot more boat through your boat tail than you would in
Oh,
the actual.
yeah.
Because I think it's probably gonna squish more than a motor case does.
The max force for this isn't nearly as much as the.
Yeah.
Associated.
Confidence in the
Yes.
self.
Yeah, I'm sure this will work, but you're the same thing is
Okay.
probably not right.
Cool.
Alright.
Six on. 80.
No.
If that takes us all the way to payload, Mackenzie is on her way, so.
It does not.
Oh, never mind.
It's like the last.
Okay.
This is low launch.
Yeah, I know, but I'm saying we got.
Yeah,
Yeah,
we
that's
put these for the normal
Yeah,
ride.
let's go to 80. Wait, nobody has an angel, let's go to 80.
No.
Nope.
Wait, I thought it's.
What do you
Uh,
got?
first call, what's it called, 70 short.
Okay.
That 7.5 inches should not be, the requirement is inches of clearance greater than space, not. And I'm assuming it's not 7.5 inches greater.
Yeah.
As if it was, it would be within the requirement.
Yeah.
Yeah, so, there's that, I have 70, I already talked about, the last one,
Okay.
so.
Now we
When you say, actually, you guys, I think it's 80 technically, but when you say ensure proper packing or whatever, how do you ensure that?
I guess.
Like.
Yes.
Plan.
Okay.
Yeah. Have a plan. Have a integrated like plan.
Yeah, but like, so just like you have just like in that first one, just like quick little description of like, have a checklist, practice it, something like that, not
Yeah,
just,
like a one.
oh, we do it.
So to have this, so like maintenance deploy is a 5, go back to the last slide. Main not deploying is equally bad as ballistic.
You may not deploy in computer five.
That's not right.
Yeah, it should be.
One of those is very clearly worse than the others. A whole lot of fives here. They should not all be fives.
Yeah.
On, I think it's on 82, you know, on something that isn't five, that's good, you should, that's good, you, things that aren't all fives, but like.
Yeah.
80%,
I'll agree with numbers.
with 80-something percent of your risk being fives is.
Very different.
Right.
Cool.
I have also on this slide, when you say for like bolts, shear fail, when you say run sims and FEA, don't do FEA on bolts, do hand counts,
Oh, sorry, yeah.
just. Like, I'm
Run-
assuming you
run the
know,
spreadsheet.
I'm assuming you know that, but like,
Yeah,
there.
that's a. Anything else? Woo!
Yeah.
Mackenzie is on her way and would like to see watching the payload section, so could we have?
Let's skip to measurements, which is around 102.
Huh?
We do avionics.
Sure.
What's up?
Just.
I'm pretty sure there was I forget what, I thought it was 88 an hour. There was a part of the risk matrix that says, main like deploys late.
Yeah, the risk matrix?
Yeah.
Yeah.
Including.
I'm pretty sure that, so the reason main would deploy late is that the attendee doesn't eject. And if the attendee doesn't eject fully, nothing is going to make it suddenly eject fully. So if the main doesn't deploy,
It's not deploy at all, or it does deploy?
yeah,
Okay.
It's that you're stuck in the two.
Yeah, like that.
That's a very small change.
There are things that can impede it slightly, but it still goes.
okay.
They're not likely, but like.
Yeah, I would say the most likely thing is that, it like comes out of the bag and it's angled.
Yeah.
I think that is the most likely risk.
Main doesn't fully inflate, it's much more likely that main deploy late.
Okay.
Yeah.
It'll probably either deploy or.
Cool.
So on avionics?
We're going to, avionics. Oh, yeah.
What slide did they go next start on?
I'm
looking
that up.
So.
Yeah, I think.
Yeah.
do we need to go?
Um,
Carly, do you know that you're taking that for this grade?
Come on.
Like what?
I'm coming.
Yeah, wait.
Are you guys playing sauce?
Okay.
What are they doing?
We're doing CRT work.
See.
What do you mean?
Most of what I have is just kind of.
117.
Search
So,
based.
are you saying-
Tasks.
I might have misinterpreted, are you saying that there will be a mini, Blue Ravens and Searing in at the same time,
Yeah.
or all three?
The easy mini is just like a backup alternator, it's not broadcast, it's just like.
But we will have three altimeter, the design has three altimeters.
Yes.
So teammates not doing anything. Why are they?
Yeah. If you get.
So one thing is like. We have a plan for testing steering and whatnot, but like, worst case scenario, when that doesn't happen, there is easy mini, like it's like right there. But if steering were.
It is also valid to consider that like,
Put it in.
none of these are
Why not?
perfectly accurate, so like, they're gonna give you 3 different numbers. If you have 3 numbers instead of 2, the one that is closest to 30K is probably closer.
Also,
I didn't think about that.
I'm pretty sure you
Definitely.
pick an altimeter.
Yes.
You pay before you.
They look at one altimeter.
This year you pick one without looking at data and hand.
Yeah.
So,
Don't they have these codes when you pick it up though, like,
yes,
That's also.
and- well,
are they gonna stop you from listening?
no,
to
you
these?
are, listen to it, but you're not allowed to like plug it in.
Okay, so you can get the apogee from each one.
No, but previously you could choose which one.
And then the
I thought you
competition.
choose something with data.
So that's.
No, you could like choose based on one.
We can determine apogee before we hand it to them. If we have 3, one of them will be better.
Very like computer did do anything for the rocket.
Next slide. 118. Brian, where does your hypothesis come from? The current draw.
Current draw of Sierra.
So I measured the previous current draws here, that was about 150 milliamps. Assuming that the only changes we made were adding 2 more devices that aren't necessarily incredibly power hungry. And no, 1 more device, the magnetometer, which is really new. The GPS is very similar and probably shouldn't have too much more power. This is honestly an overestimate probably, just to be safe. It's more reasonable to assume that S1R3 is going to be very, very similar to S1R2, give or take like 10, maybe 20 milliamps. So this just being safe.
You should, in the future, just like give us a little asterisk or something that says that these are quoted versus.
Also similarly, 120 milliamps seems really high for a Blu-ray. Do you know why that is so much higher than the, like, say, E9? Because to my knowledge, it's not doing GPS today, or it's not. Yeah. So where did 120 come?
That's just the value that I found online. I don't remember exactly where I believe.
Okay.
All I know is the Blu-ray or easy made on Windows off Barrow data.
Yeah,
So that's
it makes sense that it would be less. So like, I think last year was like 7 and like 18.
Magnitude without it.
Yeah. And I mean, if you find out it's less, you have more capacity, it's fine. But like, that is C dot. Also, you can use smaller batteries if you want.
Yeah, so going off of that, you can use smaller batteries. A nice thing to have here is like, okay, how much capacity does an 18650 have? How much, like, what is your actual operation lifespan here? Like, you know, your Siren can run for 14 hours, but your Alpha Beacon can run for 25. Like, just show those numbers.
As more research been done into how his Elven Beacon works, because Brian.
I think Jonathan was doing that. I'm not totally sure. I've not kept up
He
with
said that he kind of figured it out, I think, but I don't know.
A comment to like,
Last year, Brian, from this point in the year, Brian intended to have an Elven Beacon in, and then it was never in the UA because he never figured it out. So let's figure out how it works.
to the comment of like sequencing the Alpha Beacon, the tele GPS, so that they transmit at different intervals. How are we going to actually confirm that they do that? Because when we turn them on, it's just going to start its clock from whenever it's turned on. So it's entirely possible that when we turn them on, such that the signals overlap instead of.
the Elven Beacon is going to be on the
Okay, so which two are on the same band?
the telegps.
Okay, well, either way, like assuming they don't have a clock running before we turn them on, how do we time them against each other?
I don't know about those computers specifically, but I know other ones will use GPS time and go from the top of the minute as their offset.
I know that's what telegps.
Okay, so we can make Sierra and do that too.
It just makes sure that happens, right? Because otherwise they just say, okay, I'm counting now.
That's stopwatches are good.
I mean, like,
That would work. It's not great, but it would function.
But that would have the space of it be logical. It's not much.
This isn't about the information on this slide specifically, but I would have liked to see a wiring diagram for the main bay. I think this is the section which.
For PDR, that seems like sure, I guess.
Some of the other.
Alright, they're trying that time.
Next.
Anything on this?
I have one question.
What's the progress of the common filter?
It's kind of close. It's like it's hard. So working at the banker, he's got like a lot of it done, but there's just a couple of equations that she's. So
How much of this can be done with the stuff we have right now? How much of it are you waiting on the new thing?
So we can test, the IV parameter and telemetry, magnetometer before ICT or RPS2. The new flash, you can get to magnetometer, obviously. And testing the system as a whole, like with all our updated code, that answer the. Yeah.
What are your requirements? Like, I know it didn't change, but like, I wanna know what they are and how much is bed. I don't remember everything from this or ODR, whatever, you know what I mean? Okay.
Anything else?
Alright.
Or I guess, we should double extra for sure, make sure that the time lockout also works. That is part of like the test plate, ground testing stuff, but worst case for the Siren would be that it detects apogee too early, ejects, and then we fold in half like Helios did. That's happened on like lots of rockets now.
Many other rockets have not, the ejection started way up.
Yeah.
The other thing is that you say you're doing your radio and GPS testing between two Sirens. First question, why? And second question, does that imply that there will need to be a Siren in base station? For a base station to actually function?
Yeah, so that's the APD code, the like logo packet, basically. And that'll gonna be serious.
So why aren't we just testing it with one station?
We don't have.
If we're using base,
We should be testing how we are going to operate.
Well, that's just a different test. Like, we're just testing the functionality of what we do. It's like, you know.
Then a second test should be that make sure it works with base station. Okay.
Yeah, I plan on making an interface to the base station, so we don't need to steer into the APD code its own, but we do not have that right now, so this, the current planning is set as possible.
Make sure you work with base station after that then, or at the same time.
With your modified L1, you said you're gonna control events, how it's been, the L1 we have, just like use the injection charge from the H100. What's your plan with the modified L1?
We're building like an eBay and a no stone.
Yeah, they'll just have a different eBay with all the.
No stone, and then we'll have charges and we'll have, we'll have floating charges and visible charges so you can tell it actually works. And you can verify that you can ignite black powder, not just ignite the match.
Has any sort of preliminary simulation been done to make sure healthy mode is not much red or L1?
Yep.
Okay.
It's gonna be real Frankenstein. That's the
General thing, what's your plan for timeline of this? Like,
please.
both, yeah.
That's very dependent on when R3 arrives, which could literally be.
Do we have like a rough estimate?
Like, let's say, R3 arrives in 2 weeks.
That's a good.
That's a very good estimate, but like, from when R3 arrives, how long until each of these things can happen?
Yeah. Weeks from now. I mean, again, it's like the longer it arrives, the more time we'll have to prepare the test. So, I don't know, it's hard to say. Okay. Say soon arrives 2 weeks from now, November 6th. We can do test data collection probably that weekend. Whatever the next launch is, say hypothetically 15th or the 22nd, we can probably get it next two tested by then. So then going from there, radio and GPS software can be written for that relatively quickly, like within a week. We're already finishing up GPS right now. So worst case scenario, it could be fully tested by the end of November. But that's assuming we get some time. All the things can be done within a month.
Halo?
So payload, go to E5.
I can like, that's what nice.
I'm gonna balance. Did you kill me there? Yeah.
Yeah, we can take some time to let the fancy. Yes.
Quick comment on 85. You guys said a lot of stuff and there weren't a lot of words on that slide. Definitely, I think you should get into a lot more technical detail on the paper because again, they're gonna really like that. But also in general, like, unless there was like a bunch of info in the speaker notes that I just didn't see, someone should be able to put this, like, Mackenzie, who might generally not be able to make it to events like this, should be able to flip through and provide that.
I have a little.
Okay. And that's also because on Wednesday, we met with, the people who are making the polymer for us, and we got like a bunch more info. so
Okay.
We didn't really have time, but for CDR, there will be a lot more description of what the polymer is, and its different properties, and how that's gonna impact.
Yeah, as part of that, if you should follow, like, your, the accelerometer to the,
That was again, we didn't have to update it, but
Yeah.
we're just gonna wrap it and then put it in the same casing that we put the stuff.
Can you explain what you mean by wrapping?
Yeah, so it's gonna kind of, so the polymer is very like. It's elastic, kind of rubbery, and so the plan is to form it into a little pocket that the accelerometer can just kind of slide into, and then that is going to, we're gonna have like, what do I wanna call it, like kind of a case, but the polymer with the accelerometer is gonna sit there and it's gonna be capped off, so nothing's really moving around, in there while the data is being recorded. But yeah, that's kind of. And we just, recently, we were 3D printing little like, pieces that have the dimensions of the accelerometer so that they can get working on making, like samples of pocket polymers, so.
Do you know how you may, if you don't know right now, that's fine, but make sure you know how thick that is to get viable results, because if you wrapped it in like a 1 millimeter thick thin, polymer, you're not gonna get much damping effect because it's gonna be, I'm not a material scientist, but it's my assumption would be that it's gonna be somewhat dependent on how much like material is between the edgy wall that it's going into, and the accelerometer is going to affect how much damping you experience. So making sure that you have an adequate enough thickness to get, so you're not just analyzing the edgy twice,
And we do wanna make a test before, see which is like.
Sorry. Is the idea, they're making the pocket for you, or are you getting the material and making?
They're making.
Okay, I would just make sure you get like drawings from them, or even like a CAD model of it, so you know functioning stuff.
I had actually made this kind of proposal, this is a good, as good a slide as I just saying. Are you doing actual launch detection for it and then starting to record data? Or are you just recording data the whole time?
You're planning on the recording. You're planning stuff.
Okay, yeah, I'm not sure exactly how that all works, but try to like talk with avionics people, like make sure your launch detection stuff, make sure you don't like lose the first like second of flight.
I would say it was the most dampening does happen at high altitudes. That's the obviously that's the difference.
If your material properties are temperature dependent, do you have a temperature measurement?
We probably will, again, we will look into this. Sure, that makes sense.
When will you get the actual, material and how much of it you, and like how, if we somehow break all of it, how much time will it take for them?
Do they make like down sheet for this? We don't really use that many for this one, so
It would say giant.
Like, yes, so any accelerometer.
Relative to you.
Yeah, the accelerometers are an inch by inch. So they can get us a lot of copies. We expect to get, hopefully some samples in the next. So, good grief.
So, is this gonna be like this above and this below? Like, is this gonna be like around both sides of the thing, that graph?
Yes.
I don't know how much you know and how much you will know. But a little bit more detail about what exactly these materials are would be great. It's like TPE solid plastic layer. TPE is just thermoplastic elastomer. That's a giant class of materials, right? So if you can get a little bit more specifics about which one it is, that would be nice. If you know more about the plastic layer in the middle, that would be nice. I don't know how much you know. I don't know if they're like not allowed to tell you everything, but more information about this. Also, like, is the TPE sizable amount of the thickness of this? Like, is this to scale? Is it like 10% to 90% viscous layer? Like, what is that?
It can change depending on where you.
But once you have the material, you know what it is. Be a little bit more specific with this about the thicknesses, maybe more material properties about it.
That's similar to that. This is kind of way out in the future, but you should probably talk and like have almost like a crash course of the properties like of this, so that when you are talking to the judges, things like that, you know what's going on. And also you might want to ask them to help you again, from a polymer standpoint to help price things up.
I was the.
What's our next? Oh. Kenzie, do you want me kind of any of these slides?
I've seen this one.
Or like this slide and the next like couple, just having a picture of like the assembly, you know, like make some stuff transparent, whatever. I think is more useful than like individual parts. We need individual parts for like the detailed design and like RFM and stuff, but for this, just kind of like show like the general structure of what you're thinking. And a better way to show the information that you're trying to get across.
My only other comment, for if you're doing like the side panels of these, is making sure that, so I guess my first question is, are your screws, I'm hoping your screws aren't coming in a burning thing. Okay,
Yeah.
okay, that's covered. There are a lot of pieces like that, it's gonna be difficult on the middle, I think. But if it's sideways, I think it should be good. That was my only concern, just because there weren't any holes, so I was concerned like for the side panels on the far right. You were putting them vertically down.
They're shown better on a slide. Yeah.
Although from what I remember, it is, we
It's
did
possible
that,
to
because we
pain in the
we
ass.
did it, so it is possible to fit that on.
I thought we broke the machine.
No, we didn't, we drilled holes to the top of the head, which is annoying, because they had to blow the table to the ground, that's why that was.
Yeah.
What are those holes for on the side panels?
Those they're providing the battery. They should only be on one side.
It's the external end, yeah.
Yeah. They're providing the battery, the battery first.
The threaded holes.
And then you don't have screw switch holes right now.
Not is, yeah, but they.
And what I said before about you need some audio or visual method of making sure that you know certain steps.
Actually, that would take some time to think about, because if the payload, it's in like 2 layers of stuff,
Yeah.
so,
LED on the outside.
like, maybe we have like a little hole. Yeah, you have to have like a chef or like hot glue on the side or something. Just like it takes a bit more thought to say, but
Would we be able to see that in the?
Put it close enough to a switch hole.
Yeah.
Look
Or
through,
like, you know.
see a whole bunch of bright, like.
Think about how to do things. Yeah. We need to know it's on, that's it.
I'm pretty sure you mentioned this, but for the front and back panel, the internal views, are those slots or extruded?
Oh, it's
Okay. Okay, cause you don't have fillets on it, so it was kind of confusing.
yeah, machine related.
I was confused in asking a clarifying question.
Yeah, but it's still very active.
Anything else? Yeah, you did pick that. Okay.
Good. I have my note for it on this slide. The amounts for the accelerometers are gonna want to be as stiff as possible so that you aren't getting data from the material that. So two ways to really know about that. One of them is just make your prints denser, more walls, more info, whatever. The other one is try to find just a stiffer material. That could be some fiberfill, that could be a different plastic. Just think about it, right?
You could look into getting, well, maybe not metal, but you could look into getting like dough and machining a cavity in it as opposed to, 3D printing it out.
I mean, the bamboo stuff started nozzle, right? You get a glass or carbon filled PNG and do that. I don't think big box would have
It'd
it.
be fair, but that's like a giant wall for like.
But something
this
to keep in
much.
mind is you're not selecting like the data from the material by in itself.
How you solve it isn't really the point right now. It's just that you need to think about it.
Next question.
Like,
Show
I'm
this
91.
picture
Yes.
earlier.
yeah.
Like that's a good picture.
I would, a couple things. I have to comment about the 3D print here instead of the previous slide, so thank you. That screw switch, which I think is that white thing up there, right? And that doesn't look center line to me. I don't know if it is, it's just a perspective throwing me off, but check to make sure that's actually center line on the paper. Like the paper. Something saying. And I'm sure there'll be more clarification on the electronic stuff later, so I trust that you'll get to that, but. Some pictures, yeah.
If it's possible to put your batteries, I think, so you go bottom, put them on the wall, your batteries are probably gonna be your densest material there, and if you have shape, if that's petchy, it shears and then it falls on your clipping material. So, yeah, if you could, if there's some way to rearrange it and there's here to the bottom, I would prefer that. It's like a failure mode, you don't want it, and it's really unfortunate.
You don't want another.
Right.
Which end of this is attached to the bulkhead? So you're, the stuff, the acceleration you're measuring is on the end of a payload that can wiggle around.
Oh, yeah, that's just totally good. So,
Do you want to, what's it?
Yeah, probably.
yeah, you want those pucks of material to be as stiffly attached to the rest of the rocket as you can, so you get the best data you can.
And then we could have the battery supply.
Yeah.
Yeah, so you just like pull a couple of things, honestly.
And that solves Mackenzie's issue.
Yeah. I have something on the next slide. Anybody else have 91?
Oh, I did, I wasn't there.
Okay,
I saw this early this morning, so.
so that, you got that big long board hanging on and 2 bolts on the end of it.
That's what I said.
Yeah, that's a bad idea. Like I get the flash chip and maybe the SD card breakout only have mounting holes on one side, but I'm pretty sure that ESP32 has 4 mounting holes. No?
There's a picture here on the.
Yeah,
print
here it goes.
print something.
That's goofy.
Print something to put a little bit of support on that other side. Because let's say you're coming down a little sideways and you hit the ground like this. Yeah. That thing is very liable to just Pick itself off the board and break in half and you're having a bad day.
I'm thinking if you make a pocket for it, like then secure it, it might.
You can also just print like a little C at the end, like,
Oh.
And that Q drive.
yeah. Okay, it's like I said, you slide it in, just put it, you bolt it, it can't wiggle because it's in a thing.
A pocket carrot, you
Huh?
could say.
No, because it's we're creative with multiple sides. A pocket would be like this. You wouldn't have it
Okay.
around.
Great.
That is a big mistake. Anyway, next slide.
It's like when I think of pocket.
So I'm pretty sure all these are 3.3 volts, not 3. So like it doesn't really affect much here, but like put the right number on, please.
Same comment I had for the avionic people, again, if you just have like an extra, like, okay. With our selected battery, what is our active time, so we can like make sure that it be like.
Yeah.
That next slide.
Your accelerometers are like kind of really important for this thing. Any amount of specs about them will be great.
Yeah.
How much acceleration can they measure? Is it more than the max we'll see? What data rate can they do? And if they can only do like 100 hertz, that's kind of probably not good.
Yeah. Didn't Helios saturate a 400 G accelerometer?
It should have 100 G.
100 G, okay.
Oh, so that was good. That was like the next shit back.
That's, but it did.
Yeah, but you get the accelerometer, right? Like we see that on the line, so that's obviously not good. If you can get one that's good enough for like our shock loading when a pair two comes out, that would be great. Figure out that momentarily. I'd say there's a pretty good chance that that one is good enough, but I don't know because I just see a picture.
It gives 64, we will add.
Do you know how like sample grade it has? What? Oh yeah, that's enough.
Pretty good.
Yeah, that's good enough. Right? Just say that on here, right? It can do up to 64 G. It's 30 kilohertz, whatever.
Yeah.
You're done. Yeah, thanks.
I assume with the battery.
Oh,
So 95.
Yeah. Sorry, block tiger.
So that your data recording for this. Are you recording to an SD card in flight?
So it's a special SD card that handles the voices from the vibrations. And then at recovery, we're putting a T card into the bridge.
So you're recording to like a different thing in flight, and then when we get it, we're gonna put that data on an actual SD card, something like that. Go put it. Cool.
Where are you hoping to buy a AT650 with 4400?
That's a great question. I think that was.
It looks like two in parallel.
Yeah.
Double check that that's all.
That totally is.
There's something about battery being connected like and then wrapped or something like that. That's like silly, but it
I
was.
don't remember seeing that. Okay, then you get two in separate.
Yeah, I was like, don't check before you buy it.
I just got two.
I didn't know how to. I said that you.
So it's like a 2-piece cell. Is that okay? Cool. That makes more sense.
You have at least two layers. That means it's not two layers.
Oh, what's it getting from the flash door? Is it I assume that it was implying that the bike control is the flash door.
The flash isn't on board isn't big enough, and we don't want to write to SD in flight, so it's using external flash chip.
So okay, so it's going back is only when it's after the name is transferring from flash back to the controller into the SD card. Okay, that's.
Thank you.
First figure is so funny. That's it.
They don't.
There's like, yeah. Why is the other side of that switch connected to ground? Like it totally doesn't need to be.
Yeah.
It can just be hanging out. You don't even need a dual for a switch, right? Just.
I mean, the screws are just apart.
Yeah. Okay.
The switch does not have sleep trouble. That's a dual position.
Okay, this is just convention.
Yeah. You can just use the standard switch. That you
What you said?
can just use like the default switch. Yeah.
Yeah. It's just a switch, it's a single hole, single first switch,
Thank you,
and then
thank you.
you'll grow it, it has the other side of the ground, just
Yeah.
put in the right
Thank you
switch.
for the clarification.
I didn't realize that.
Oh, I got you guys, no worries.
You guys want to comment for this slide?
So the switch is wrong.
Well, also.
Oh, and my comment about cleaning it up was just like before when I was looking at it, I for a split second thought you had two different grounds and I was like, so, but yeah, it's just kind of different. I can show you like another way to write, to make circuit diagrams that Ben showed me how to do. This is good for like the physical feel of like feel of it, but there's like cleaner ways to do it. Yeah. I can show you.
Yeah.
If you want to make it more obvious that these are all the common ground, you can like just put the ground directly on those grounds instead of having like some of them tied together and then some of them not tied together. It's perfectly acceptable to just say ground, 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 and not have like connected together.
Yeah, they're all the same symbol for ground, and they all just say G and D, and there's no like qualifier after that, they're all implied to be the same, it doesn't.
All the lines are
Great. Next.
Yeah, question. Isn't the bottom of the pillow square?
Yeah.
Yeah. This is just the bottom plate, like.
Oh, so-
Yeah,
I think that's the second, I think that's the part.
Yeah,
Like we're looking up front.
So that is being fixed to a square.
Yes.
Okay.
That was.
So I know that's the bottom bulkhead, but you had the puzzle piece where the front plate is meeting it. Yeah, and I was like, what? This is the last slide, right?
No.
So I was gonna say something else for your electronics, when you're planning out, when you're gonna like, I'm assuming you're gonna like rearrange some things. Please keep in mind, where stuff is connected. Cause when you have your wire management later, you don't wanna be, like, for example, your batteries need to be closest to your buck converter,
Yes.
right? Yeah, so when you're rearranging it, please put it in an order that makes sense, so that way you're not like, there's something that, like, this is from personal experience where I had to make some extensions in places, and you know, in a payload that's gonna be like, you know, moving, it's not the place to have, sketchy connections, with your JSTs, so, just keep that in mind, when you're like placing things and making sure like systematically it does flow and stuff isn't gonna be reaching. Okay.
Anything else in payload at all? Fine. Oh, I have one actually.
Okay, yeah.
I can't exceed a. Like 100, I'm just like 100. That shouldn't be green.
I can't see that it's 11, but.
We should do reactivity.
Oh.
See one
Oh, well,
like,
okay.
and stuff.
Okay,
You could throw a banana.
okay, maybe I'm wrong.
But also you're like, good enough for that.
Oh.
Okay, great.
What is smoke detector, they get some radiation.
Anyone else have anything?
Great.
Great. Thank you. Let's do measurements. Okay. Start first in measurements.
Okay, so, the normal eBay does this, you should do it too, those blocks you have coming out for the, screws, right? Whatever the, like, see down face is gonna be when it's printing, just put a little slope on that, so it prints nice. Ryan, for you, the normal eBay has that, Ryan did it in the past, you know, did it, just talk to them, just do it.
How?
Somebody else has a name and he doesn't know, that changes.
Maybe go, I do know, it's Canadian ground, asshole.
Did you learn it today?
No. I'm sure I learned it in circuits at some point.
But what's the distance of those, like the diagonal distance of those holes? You know, or if you know the side distance, that is.
We wish that.
Like what distance between any two, those are the holes on the top that go down, are those are those the threaded rod holes?
Yeah.
Okay, do you know what the distance between the two holes is, like?
No, I just kind of put them on the edge just so that I know it doesn't interfere with
And how big is that edge? How big is that box? Is it also like 10 centimeters? Like how big is that square, the whole thing?
Oh, on top?
Yeah, Well, like the side length, the side length of the,
Are you just asking, do you know that it doesn't hit any angles?
yeah, I'm just asking, do you know the dimensions off the top of your head about what that is?
Yeah, I know for a fact those holes not.
Okay, lovely, yeah, that's,
Do you have a like battery cap to keep them?
No, I didn't realize that was just picture.
Okay, cool. I also think it could be compressed a bit more. Not super necessary, but like it would be possible, maybe good to do.
What's the point of having all the like, it goes to a circle thing?
What's the point? Oh, we're thinking more like stability reasons. I mean,
Is it off grid rods already?
that was actually a very recent plan to the thing, but I mean.
Well, now that you're off grid rods, I don't think you need to.
it doesn't hurt.
It does look.
I mean, it's just
It
like.
looks, and that's a good enough reason.
Oh, wow.
I will.
It's building on that.
Yeah,
Let's get a couple more fillets on there.
you could also use 448 volts.
Yeah.
Alright, next. Next comment.
Alright, what's next slide?
Next slide.
Next slide.
Not that I don't trust your math, but has anyone who is not currently in eSafe checked this?
Another comment, it doesn't matter because this is a 3D print and you don't know what your infill's gonna be.
Oh yeah, actually, I did, I know you're gonna say it, I did want disclaimer, there was some assumptions made, like, for example, this is assuming that it's a uniform 3D print, which most likely would not be, but I feel like getting a factor safety of 89 kind of gives a good leeway.
And I would disagree because, I mean, I don't think it's gonna break, right? Because we've done this eBay design hundreds of times before, but this math is just not relevant because it's completely dependent on how it is.
Do your worst case scenario and then.
Also,
This is a best case scenario.
Threaded rods will take most of your load. Yeah, I didn't mention it because it was a late addition. I didn't know y'all were doing that. Now that you're doing that, I would do the bending of a threaded rod, which is also more valid math. Because like
Like, is this number assuming completely solid homogeneous veggie?
I believe so.
Yeah.
Yeah, that's nowhere near reality. Like, your factor of safety is probably more like a 3.
Because it will drop both your maximum stress and your moment of inertia, but our second moment of area. So
Yeah, you're gonna have way less area, you're also gonna have not good.
Okay, yeah.
layer on things.
just do threaded rod.
Next comment.
Where'd you get 60 G's decel?
I mean,
Comment from Emma was she doesn't think that's correct because in like orbital or flight or something, they said ballistic incoming satellites pull 30.
okay, well, our accelerometers from Event Horizon read 60. Well, it read like 45 in two perpendicular directions, which makes 60.
Okay.
So yeah.
Alright.
Just 60.
Also, is that 30 G's ballistic in the atmosphere or yeah, it hits the ground and hits?
That was, yeah, that was that.
In atmosphere.
Yeah,
And
that's like
called
yeah.
an atmosphere and a parachute inflating are completely different.
Also, 60 G's is ground hit.
Alright.
Oh, okay, well.
But yeah, we have measurements to back it up.
Okay.
too.
Alright.
Next comment.
Next slide.
So, I'll go first. I don't know if you're planning on having strain gauges in multiple orientations, but if you do, it might be worthwhile having one of those that's curved the other way so that it can conform to the surface or whether it's facing like up. You get what I'm saying, right?
Yeah, but we do also have like, I know it's shorter here, but actually like, the ones that we have, there's like a 5-inch wire, so I mean.
Okay, if it's not an issue, it's not an issue, but like with how short it was in the picture, I was like,
You know what plastic you want to print it out of? Okay. Well, I think like some adhesives aren't great on PETG, so like it might not be a huge issue, but I do a bit more research into like for your specific adhesive and plastic. Is that good?
So, on the strain gauge modules, thank you a little potentiometer for presumably like tuning it to D0, right? Yeah. You might wanna put like a little dot of hot glue or something so that doesn't start turning in flight and your zero changes in flight, cause then your data's kinda not useful.
Yeah, that would be a good idea.
Oh, yeah. Yeah, sorry,
Next slide. How are you mounting these strain gauges to the tube?
the strain gauge, oh, like the actual, essentially like, yeah, we have, we need to get it, especially adhesive for that, there's like a process for like actually adding the strain gauges to the tubes. Regarding where we, alright, well, regarding the actual adhesives, we did get a sponsorship from a company to actually give us a kit for adding strain gauges.
Which company is this?
Micro measurement.
Okay, it's the one that has not come yet.
Oh, wait, according to that. But yeah, so we have a plan for like how we actually want to do that.
And it's something that's meant for this that isn't going to alter your readings by very much.
Yeah, it's meant
But like
for-
if you just set it also CA, right, that's gonna affect your measurements because it's a different standard.
Yeah, it's for carbon fiber, like.
Alright,
good.
Well, it's not in the world, update the overall screenshot when you make it.
Oh,
You didn't have to do screenshot.
how is the uppermost strain gauge getting connected over a point of separation?
that's, what do you mean? Oh, that's the VGA cable. Oh, you should.
Yeah,
Yeah, I'm sorry, that was.
It's a connector, not VGA. VGA is the video standard.
Right.
Actually.
Adding to that, also how you're gonna go through the protection bulkhead, given that there can't be holes in it.
Yeah, that, alright, there's a lot of early conversation.
Yeah, like,
In terms of putting strain gauges in the boat tail, I guess if the wire runs along, you're planning to actually mount the board in the straight section.
Yeah.
And then also, I think it would be possible to stick one of these out of a hole and attach it to the outside of the fin if you really wanted to. I don't know if like aerostructures would be happy, like would want to do that, but like from what you explained so far, from like a measurement standpoint, I definitely think that's possible.
You can put it in the fin.
Yeah, or you can build
Because
it.
if it's on the fin, there's a good chance that your Mach 2 flow just eats in.
This isn't the thing directly now, but make sure you have an actual plan for integrating this on like in the actual.
we could put it.
Yeah, because it's very, our plan, what happened in the past is very much like each thing's its own separate thing and then they come on together as they need to. But there's going to be the strain gauges and the wires throughout this that will be at every step of the process.
Robbie and I have been talking in depth about CPR, like a whole.
Your RFN is gonna need to have a lot of information on this process.
Any other comments or next slide? Thanks.
My comment is for your recovery bulkhead. Can we just attach a strain gauge to like the cable itself? Like, so we're like even more directly measuring the recovery force?
One problem I have with that is just how, because the idea, I didn't have an investigation, my bad, is that the idea of getting past that, recovery bulkhead, there's a VGA cable to have like a connector connected to the bulkhead, and then have the cable directly connected to that connector. So I don't exactly know how to be able to have separate like 3 wires to attach to this module, so that's why I was saying like, let's just stick on the under. But
Also, I feel like the quick link whipping around might just like break it off.
I think that you will. Like,
You just like
Yeah.
run the cable like along the top of the U.
I guess, yeah, you could.
Assuming it's small enough.
Yeah.
But yeah, no,
It might also be too small.
that makes sense.
So you want to measure deformation of the nose cone. Would it not be better to put it further up on the nose cone where it sees more aerodynamic loading?
So we're initially thinking of bringing it above the eBay bulkhead, but that could be a challenge since we didn't want to drill a hole through that bulkhead and eBay exposed to any pressure changes due to recovery deployment. So it seemed easier just to start it below the bulkhead.
Bulkhead and seal are not a high glue.
Also flat, thanks.
Oh yeah, and also we didn't want to have like, because from what we've been discussing about integration, we want to have a lot of extra slack wherever we're putting these strain gauges and having extra slack to the CBA, that's the CBA, that's no go, so.
Not for me.
So with cross transfer bulkhead, just to confirm, you are not putting strain gauges on the bulkhead, it's on the surrounding bulkhead.
Yeah, just
on the-
I was just a little concerned about where the strength gauges were, the issue to the stuff, just as. Boom, and things go, things get
Yeah,
hot with fast.
but it's, yeah, we won't have strain gauges, we'll have the strain gauges for that.
Yeah, I think it's in an okay place for it.
The wires, the VGA connectors, right?
Yeah.
The upper one, there's a wire that goes to a strain gauge that's on the nose turn.
Yeah.
Are you worried about that wire getting cold? Or is it just gonna, like, is it a thick wire that goes straight to the connector, or is it?
Yeah.
Okay. To the straight to the module, I mean.
Yeah, if you think wires usually module, and then we can connect the small wires to the big cable.
Okay.
That's what I'm
I
thinking.
just make sure you're not worried about. Like Alex said, like it gets cold very quickly.
That's what we had, I think, too, but yeah, we got a lot of
Oh,
stuff.
okay.
You can probably do like what we did with the cable cutters for the nose cone previously, where you have. In that case, it was a shock cord, right? You have some strong line to take the load, and then your wires that are carrying your data go alongside it a little bit extra length, so that your wires don't actually stand out.
Just be cautious of slices if you say. But like there's something about it, but just make sure you.
Any other comments or next slide?
I might be silly. Hold on. Yeah, well, I feel like the math on the string, 835, 40, okay, maybe not. Maybe, I'm going just quick.
I guess the same comment I made was 14 about how you.
Oh, yeah, I put that in the slides, but
Do that.
Wait, those
Yeah, the numbers don't make sense.
All of these are 25% higher than they are just by
oh,
multiplication.
sorry.
Is that because of like voltage conversion stuff?
but not all of them.
Well, no, because B is that, okay, yeah.
Oh, because 80%.
80%,
Okay,
okay,
that makes
size
sense.
is,
Oh,
that was ours.
Okay, that makes sense.
okay, that. Yeah,
That's gonna be a bit more explicit, but you didn't.
yeah, it's a little unclear, but.
When are we turning this stuff on?
Actually, you connect it all, like,
So,
no,
so it is on and just like recording data.
so it's, okay. It's, data is gonna go into our unit, but it's not gonna get stored, so it's just, I don't know what you call that, but it's.
So, okay, so everything is on when we integrate the rocket.
Yeah,
And then sorry, you're also doing launch detection as well?
yeah, the Arduino Nano has a accelerometer on it. So we can,
Yeah, we don't have right? And it doesn't matter if we go high then.
Yeah, I don't know.
Yeah, I was gonna say, so, same comment to you as the payload, it's just like. Make sure you get that launch detection working very well, like I would say, if possible, see if you can work with Sear and stuff to say like, okay. Test your stuff with an actual launch, like.
Yeah, I think.
I am just imagining. We go to the rocket after it lands and it didn't detect launch and. Both measurements and payload just have done. Like I recorded no data.
Or detected launch when you like put it on the rail. So
Yeah,
I heard movement.
You have a cable going by the eBay already. You could have it connect to a Sear and have Sear just flip a pin when it.
We don't have any cables.
But you have the
Not
D,
very
you have the
far,
D
but-
sub, so you could.
You can't put cables.
You could put another voltage connector on.
Garrett, did you just say connect it to Siren?
Yeah.
No.
Why not?
Two components, critical
Okay,
components
then you
failed
could-
last year because they were connected to Siren. No offense to you guys.
Yeah, use that as a backup.
Okay, go next slide.
Have both.
Great. I may not be doing math wrong, but are you dividing, shouldn't it be multiplying by 0.8? Am I doing that wrong?
Because your 80% efficiency starts on the other side. Right. You bring that in. You can also double check it because you're going from 30.
I think the slide could just be worded a bit better. Like, I understand what it's saying, but like, it's a bit hard to read. With like, what like a pair about, like, you know, the six values.
Get 80% efficiency for a while.
Recording that was from Ryan, but actually, I'm pretty sure based on the data sheet, they usually like 90.
Yeah, that was a very, not 95, like 90. Oh, yeah.
I think depending on load and
Yeah.
whatever.
Yeah.
And it's very conservative estimate, which is fine.
Okay.
Next.
Alright, next slide.
Yeah.
Got a whole bunch of stuff connected, hours around.
Yeah, so it's just kind of, I talked to you earlier about this, but I wanna, if anyone else knows the answer to this is the same thing for payload. I made comments on both of these slides, or actually, I think it was a different slide, but it applies here. You have a bunch of string gauges, string gauge modules. You said each one is 200 milliamp max draw. What? What? For power, yeah. No, that's not each one. That's
together.
Oh, it's together?
Yeah.
Each one is 25.
You should clarify that.
Okay, then clarify that.
Cause I asked Ryan,
Are you
Ryan, I
worried
had the
about
same stuff.
wire gauge?
No, I'm worried about overcurrents on the nano. Because the nano has max current that it'll
Hey, talk about the nano.
yes, but it's connected to the nano, which means that is the current that is.
No. The only
No, they're
connector
connected to
between
the
them is through the level shifters for logic level.
Okay, regardless, you should check your components for max current, because I know that what you should check what the max current going into the nano should be, because overcurrents is a thing, and then Arduinos have protection against it, which is good, but it's in most cases, but it's bad when it decides to turn the board off because the current is
How
too
this circuit's laid out, that's not gonna happen.
I mean, I think the better thing to check would be how much current the analog to digital can handle.
I know, I'm saying all components, I'm saying specifically, I know the nano does that, so check whether the ADC does that too.
Check your max current.
Yeah,
great.
Alright,
Next.
next slide, just check. Next slide.
Next.
I can tell you right now. Yeah, me requirements, sure.
I want next one.
Next.
I will.
You mentioned that you can sample at 30 kilohertz, which is great.
What are your?
Do you? Well, that's a good question too. The storage capacity to accommodate that.
Yeah, the Arduino has a flash memory of 16 megabytes.
We cannot do 30 kilohertz.
Oh, okay, we're not doing. Okay, what are you sampling at?
That was the question. Going to.
Alright.
You know it.
Probably like someone.
If you don't know and you don't have a reason why, then.
Everybody knows.
Okay.
Also, like, aggregate between all of the testers or all of the string gauges.
Here, I know you said that.
So that comes out to
five.
Great.
So,
It's about
5K per is probably fine.
Great.
Yeah.
I'm at the
Yeah,
bench.
okay.
I think that meant like total sampling.
Alright.
Anything else? That's the last, that should be that.
Yeah, you better run that close, Gary. I have 45 seconds. Thank you all for being here.
Don't leave any Red Bull cans around.
Yeah, but.
You actually.
Yeah.
I don't even know that I realized.
You guys.
That was good. Wait, like,